There are 8 power channels, and HTV for this mission is carrying enough lithium-ion batteries to upgrade the power channels on the port truss. For this mission, there are 4 sections of the truss that have the power batteries to, again, 12 nickel-hydrogen batteries to be swapped out with those lithium-ion. Kunotari is a large spacecraft, so once the lithium-ion batteries are swapped out with the 12 nickel-hydrogen, 9 of those nickel-hydrogen batteries will be put back into HTV. Once HTV departs in the November timeframe and is re-entered into the Earth's atmosphere to dispose of the cargo inside, the 9 nickel-hydrogen batteries will be disposed of. Remaining 3 will be stowed permanently on the station's truss, not as spares, but just stowed. During today's broadcast, we are scheduled to hand over communications, video communications and audio from the various TDRS satellites. Those are tracking data and relay satellites that provide communication to and from the International Space Station. Right now, we're in what's called a handover period, handing over from one satellite to another. Now regaining some of that communication, the visuals of HTV, as it sits just about 40 meters away from station and is still approaching at a rate of about 0.1 meter per second. The next milestone after the 250 meter holding point is going towards the 30 meter holding point. It'll remain there for a while as mission controllers continue to go oversee some checks, make sure that all the systems of HTV and the International Space Station are ready to maneuver to its final capture position just a few meters away from the International Space Station. That should give the astronauts Drew Feustel and Serena Aunen-Chancellor, NASA astronauts in the cupola workstation right now, the bay window facing downwards towards Earth with the controls of the station's robotic arm to actually maneuver that into the to capture HTV today. Again, the capture is scheduled for 7 a.m. Central Time. HTV and the International Space Station are in an orbital daytime right now, 260 miles above the South Atlantic Ocean, just south of the border of South Africa. A great view of Kunotari as it approaches the 30-meter holding point. Awaiting confirmation that HTV has leveled out at 30 meters. As HTV continues to level out at 30 meters, you can see the southern coast of South Africa just behind HTV there. Telemetry from HTV is looking like it's holding.
Station Houston on 2 for HTV. Confirm 30-meter hold, then set up and brief for capture for step 8 and 1.102.
Copy, step 8, Houston.
Capcom Aki Hoshide talking with Serena Anand Chancellor next to Drew Foystel up on the International Space Station, looking for confirmation of the 30-meter hold. Looking good from our view, but of course, Foystel and Anand Chancellor have a much better view, waiting for confirmation from them. just over an hour away from the scheduled grapple time of HTV today. 30-meter holding is looking good so far, waiting for confirmation from the crew. Consumables are looking good. HTV poised to be captured on time today. This is a view of the Cuckoo workstation on board the International Space Station, providing telemetry from the International Space Station about the HTV cargo craft. From this angle, you can see it's just about 30 meters away. Once it departs the 30 meters, it'll get into the capture position right in front of the station's robotic arm there. Just behind HTV there, you can see Madagascar as we're passing over the northern coast and over the Indian Ocean. As the crew eagerly awaits the 5 tons of cargo inside, HTV holding at 30 meters, doing a review here in Mission Control Houston for departing the 30 meters and getting to the capture point. Again, inside are 5 tons of equipment and supplies and experiments. One experiment on board HTV-7 is a small re-entry capsule designed by JAXA that will be assembled by the station crew prior to HTV-7's departure this fall. The cone-shaped capsule, measuring 2 feet high and just over 2 feet wide, is an experimental technology demonstrating JAXA's ability to return small Japanese science payloads from the station for expedited delivery to researchers. So following HTV-7's departure from the station and several deorbit maneuvers, the capsule will be ejected from the spacecraft's hatch for a parachute-assisted landing off the coast of Japan.
The approach to capture point.
Copy that. Thank you.
Serena Anand Chancellor confirming that HTV is looking good. They are ready for HTV to depart and head towards the capture point just a few meters away from the station, right in front of the station's robotic arm there. Meanwhile, here in Mission Control, we're getting a verbal go, no-go from all the mission controllers, making sure all systems are go to get ready to receive HTV and the 5 tons of cargo inside. As the International Space Station and HTV are flying 253 statute miles above the Arabian Sea, about to approach the west coast of India. HTV holding at 30 meters, about to depart towards the capture point once confirmed. The go, no-go pull around here in the room looks good, ready to depart that 30 meters here soon. You can see the station's robotic arm at the center, bottom center of your screen, sticking out towards the horizon of the Earth. Just to the left there is the Dexter mobility unit that has the ability to actually will be a large part of the function to take out some of the lithium-ion batteries from HTV once it's docked and put them into position and to get ready for some upcoming spacewalks to actually complete swapping those new lithium-ion batteries with some of the aging nickel hydrogen batteries. To the left there is the station's solar array, and at the very bottom is the Japanese Kibo laboratory, to the right being the external payload that allows experiments to be sent out from the Japanese airlock outside to be tested in the vacuum of space. Also inside HTV is a new facility called the Life Sciences Glove Box. There's already a glove box inside the space station right now called the Microgravity Science Glove Box. It allows one crew member to stick their hands in and maneuver some science experiments or fluid experiments from the inside of the glove box. This new glove box will be a little bit larger, allow two crew members to stick their hands and conduct some experiments. And once it's taken out of HTV, it'll be placed in the Kibo module just at the bottom of your screen there. Just under an hour until the scheduled capture. Again, looking at 7 a.m. Central Time for a capture today. A few more minutes until we get a go-ahead from the flight controllers here in the room, and of course the crew, who have a much better view of the HTV and are at the controls of the station's robotic arm. Robotics officer reporting that everything is set up for them to actually take full control of the robotic arm for capture today.
Station Houston on 2 for HTV. HTV is ready to proceed to the capture point. Expect approach to resume shortly.
Copy, Houston.
That was Capcom Aki Hoshide reporting to the crew. Again, Serena Anand Chancellor and Drew Feustel in the cupola.
The question, are we still expecting HTV grapple to be on time around 1200 GMT?
Yeah, Drew, looking at the lighting constraints, that's what we're looking at. It's about a 1200 capture.
Okay, copy that. And is part of that crew discretion based on how it looks once we get to the capture point?
Yeah, that's correct. What we're concerned is looking at the blooming effect of the lighting when you go in for capture.
Okay, copy that. Thanks. We'll let you know how it looks.
So a little bit of back and forth from Drew Feustel, who's at the controls for the station's robotic arm, and Aki Hoshide, the Capcom, communicating with the crew today. Looking to depart the 30-meter holding point here soon, still holding, but should be departing and getting into the capture position just in front of the station's robotic arm. In the meantime, we are looking at an upcoming sunset. The Terminator line just right now over Thailand as the station approaches the west coast of India. Once we cross into an orbital nighttime, we'll have to wait until the sun rises again and think about exactly where the sun will be positioned to avoid any sort of glint or extra sun rays in the astronaut's eyes. Looking for the right position and the right time, and that seems to be right on time at the 7 a.m. Central Time mark. Just about that time, we'll be just past an orbital sunrise and ready to go in for capture.
Station Houston on 2 for HTV. HTV has begun approach from 30 meter. Monitor per step 9er in 1.102.
Copy, step 9er.
And with that, you heard confirmation from Capcom to the crew aboard the space station that the HTV has departed the 30-meter holding point and is headed towards the capture position right now. The rate is slow and steady to go these few meters, about 0.02 meters per second right now. Capture position will just be about 10 meters away from the station. International Space Station over northern India right now, about to cross the border to China. Over China is the terminator line. At the rate that HTV is headed towards the capture position, should arrive at the capture point during an orbital nighttime. The crew will have a great view of HTV though, and we'll see a little bit from the International Space Station's lights as it gets to its capture position. And after it's confirmed and holding, we'll wait till an orbital sunrise to move in for capture. That again scheduled for 7 a.m. Central Time today. To list off some of the other things inside HTV, there's a new sample holder for the electrostatic levitation furnace, the JAXA ELF experiment, a protein crystal growth experiment at low temperatures, an investigation that looks at the effect of microgravity and bone marrow, the marrow experiment, a very common experiment aboard the space station, as well as a few express racks. Of course, HTV is a large vehicle, over 10,000 pounds of supplies and equipment and experiments on board. Handing over video communications from one TDRS satellite to another. Tracking data and relay satellites allow video and audio communications from the International Space Station. Defaulting to some of the neutral screens here, we're only expecting a few short seconds of a handover, should be regaining video communication shortly. Again, leading the teams here in the room of Mission Control Houston, International Space Station Flight Control Room, is Flight Director Zeb Scoville. And the voice you're hearing communicating to the crew aboard the International Space Station Capcom Aki Hoshide. Matthew Wilkinson, the visiting vehicle officer on the other side, communicating with JAXA flight controllers in Tsukuba, Japan, just outside of Tokyo. Everything looking good so far. Still receiving telemetry from HTV. Still at that slow and steady pace, about 24 meters from the space station at this point. It's been just over a 4.5 day journey for HTV after launch on Saturday, September 22nd, U.S. time. Now, as the International Space Station and HTV fly over central China, you can see the terminator line just there in the distance, about to enter an orbital sunset. Into the nighttime is where we will have HTV arrive at the capture point. Crossing over the terminator line into an orbital sunset, still getting a little bit of light from the sun. Soon we'll transition to the International Space Station's lights, external lights, which will still illuminate a little bit of the HTV as it continues to approach its capture position, and we can monitor it. We're looking at about 9 or 10 meters away from the International Space Station for capture position, and we'll get confirmation of holding from the crew once it's there. European Space Agency astronaut Alexander Gerst standing by at the Cuckoo workstation that you're getting a view of. This is a view of the workstation from one of the cameras on board the International Space Station. At the bottom right, you can see VV to ISS. That is the range of HTV as it continues to get closer to the International Space Station and holding at a range rate of just about 0.02 meters per second. We might have about 4 more minutes of sunlight from the sun as it continues to set into an orbital nighttime. Still getting some nice views of HTV as we cross over the terminator line. Great high definition view of HTV as it continues to approach the International Space Station. Just about 14 meters away at this point, 0.02 meter per second towards its capture point, about 9 or 10 meters away. As it approaches, you can see some of those thrusters firing to orient itself into the right position, make sure it's continuing that slow and steady pace in the right orientation. Might have about 1, maybe 2 minutes of sunlight before we switch to the space station's external lights. As it continues to approach, keep sending in your hashtag AskNASA questions. We'll be taking questions about HTV and the space station as it continues to approach. We have one from Melissa, who's asking on behalf of 5-year-old TJ, who wants to know if there's a steering wheel on the space station. So actually, the crew of the space station does have the ability to take control of the orientation and position of the International Space Station if necessary, but it's not part of their regular job. It's actually done from here in Mission Control Houston. There's several positions here, flight controllers, who monitor every aspect of the International Space Station, its systems, including the orientation. There's a position here called the Attitude Control Officer, or here it's called ADCO. They monitor the position of the space station, including its orientation, and have the ability to turn it or position it, or even the solar rays if necessary. That's sort of the steering wheel portion of the International Space Station. They are monitoring, making sure the space station itself is in the right position, holding steady as HTV continues its approach to the International Space Station, now about 12 meters away from the station. Again, the capture point about 9 or 10 meters. We'll get confirmation of its hold once it arrives. Another question from hashtag AskNASA from Marshall Mello. Is the capture mechanism something akin to an electromagnet or more like a claw? So the capture mechanism is the robotic arm itself, the Canadarm2. At the end is something called a latching end effector, and from that you can sort of guess that it's more like a claw. There's a series of latches that are going to go over. From this position you can see it's kind of a circular disc with 3 prongs on it. That's where the actual latching end effector will actually go into. At the bottom you can sort of see from this HD view there's a line and sort of a black perimeter around that line. That's actually a pin. And the space station's crew will align the camera from the station's robotic arm. It's sort of pointing towards HTV at this point, but they'll align it with that pin and move in to capture it with those claw-like mechanisms. There's a series of stages for capture. Once a second stage capture is confirmed, that's when all the claws and everything have driven to secure that capture, and allows the robotic officers to take over from the crew who have just moved the robotic arm into capture the vehicle. The robotics officers will actually maneuver the arm itself and place the HTV right in front of its berthing port at the Earth-facing side of the Harmony module, which is at the front of the space station. The HTV is still approaching just over 10 meters away, still in an approach configuration. In the meantime, continue to send in those questions using the hashtag AskNASA. HTV still approaching, just under 10 meters away at this point. HTV and International Space Station in orbital nighttime right now. You're seeing the views, the cargo vehicle and robotic arm lit from the external lights of the International Space Station. The two spacecraft flying a few miles northeast, actually quite a number of miles northeast off the coast of Japan. There in Tsukuba, Japan, are the flight controllers monitoring HTV's approach today. About 8:20 p.m. Local time for them. Just 6:22 a.m. Central time here in Mission Control Houston. Working together towards grapple of HTV-7 just over 30 minutes from now. Everything looking good so far for an on-time capture.
Station Houston on 2 for HTV. Confirm capture point hold per step 10 and 1.102.
Houston, step 10.
There's Capcom Aki Hoshide here in Mission Control Houston reporting to the crew. Aboard the International Space Station, you heard a confirmation from Serena, Anand Chancellor. Good readout. The HTV is holding just over 9 meters away from the International Space Station. You can see right in front of the station's robotic arm. Even with the lights from the space station providing a pretty good view, the plan as of now is to wait until sunrise to have an on-time capture of 7 a.m. Central Time.
Station on 2 for HTV-7. Capture point hold confirmed. We can see the grapple fixtured within the capture volume on both camera views.
Copy all.
Hard to see during an orbital nighttime of the space station and HTV. Flying in tandem, HTV just about 9 meters away from the space station in its capture position as the two spacecraft fly together over the North Pacific Ocean, 255 statute miles above the Earth.
Station Houston on 2 for HTV. FRGF SEP is enabled. Prepare for capture per step 11 and 1.102.
Step 11, Houston. Houston Station on 2 for HTV-7. The PCS HCP LED status matches that in the figure. Capture prep is confirmed and crew is ready for HTV capture.
Copy all. Stand by for capture. Station Houston on 2 for HTV. Go for HTV-7 capture sequence, step 4 in robotics procedure 1.110, HTV capture. Begin monitoring the backaway cue card. Happy hunting. And make sure that you're good with the lighting.
Okay, Houston, copy. You were talking about right now. It actually looks pretty good to me, and as long as the lighting conditions stay stable, which I think they will for the next little bit, seems to be some time before we get into sunrise, I think we may be in good shape to go for it.
Copy, 22 minutes until sunrise.
Okay, thanks.
So, good poll here in Mission Control, and read from Capcom Aki Hoshide to the crew that they still have 22 minutes till sunrise, and as long as they're comfortable and everything looks good, that they can capture it a little bit early today. The lights will be a little bit more consistent from the external cameras, and they're evaluating that right now. And if everything continues to look good and they're still within the within a safe window where they won't have an interference from the sunrise in the middle of capture, again, still about 21 minutes left of the darkness, then they'll go for it early. So we'll stand by.
Houston Station, Space Ground 2, we're going to proceed with grapple.
Copy.
And confirmation from Drew Foysel aboard the International Space Station. He's working with Serena Anand-Chancellor next to him at the controls of the station's robotic arm. European Space Agency astronaut Alexander Gerst looking at the telemetry. Everything's looking good for capture a little bit early today, so they're going to go for it. Crew on board the station still configuring the station's robotic arm, getting ready to start moving it in for capture. HTV is looking good, and holding at 9.2 meters away from the station. All the flight controllers here in the room and with all of our partner agencies are ready to go. And confirmation that the arm is in motion. Heading in to capture HTV a little bit early today. Arm is 3.5 meters away from the station, from the HTV, and closing. Two and a half meters away. 1.5 meters. 1 meter away from capture. Now over the pin. Capture initiating, contact made. And looking like a good capture.
Houston Station on 2, we see load safe.
Houston copies.
Copy. We have good confirmed capture of the HTV-7 cargo craft the cargo craft and the space station orbit 251 statute miles above the North Pacific Ocean, 6:34 a.m. Central Time today. Flight controllers in Scuba Japan, clapping, capture sequence is fully completed. Successful capture of the HTV today. Flight Director Zeb Scoville congratulating flight over in Scuba Japan, welcoming the HTV and the 5 tons of cargo inside to the International Space Station after a successful capture today. The first contact capture was 6:34 a.m. Central Time. 8:34 p.m. Tokyo time.
Houston Station on Space to Ground 2. HTV capture is complete. The arm is safed. And I just want to say that we're delighted to see HTV-7 arrive at ISS, thanks to the JAXA teams for working so hard to successfully launch this vehicle in spite of the recent challenges with hardware and weather. Thanks also to CSA and the Canadarm2 for providing the capability to grapple all of our cargo vehicles that carry critical cargo and supplies for the crew on board and ISS. It's always breathtaking for us to see another spacecraft orbiting alongside the space station and join up on this incredible international journey in space.
Station Houston copies all, and thanks for the words. Congrats again on a successful capture of the 7th HTV, bringing more batteries, racks, and other goodies to the International Space Station. And 筑波の皆さん、この通り7号機の無事到着おめでとうございます。
So some congratulatory words from Commander Drew Feustel aboard the International Space Station at the controls of the station's robotic arm, working with Serena Anand, Chancellor of NASA, Alexander Gerst of ESA standing by looking at the telemetry. A successful capture today, 6:34 a.m. Central Time. So a quick overview of today. The HTV cargo craft launched on Saturday, September 22nd. 4.5 days later, it arrived and was captured a little bit early today. They were going to wait for the sun to come up, get some nice view of the HTV of the sunrise, but the external lights of the station provided enough lights, and everything was coordinated early enough where they captured it a little bit early today, 6:34 a.m. Central Time. Inside HTV is 5 tons of equipment and supplies and research experiments, including 6 new lithium-ion batteries that will be swapped out for 12 nickel-hydrogen batteries on some of the station's power channels. Those will be conducted over a series of spacewalks scheduled for sometime in Expedition 57. Drew Feustel and Serena Anand-Chancellor in the Cupola workstation captured the vehicle today, assisted by ESA astronaut Alexander Gerst looking at some of the telemetry. Flight director was Zeb Scoville, Capcom, Aki Hoshide working with VVO Matt Wilkinson. And of course, the teams over at JAXA Mission Control in Tsukuba, Japan. The vehicle was captured a little bit early today, as I said, 6:34 a.m. Central Time, 8:34 p.m. Tokyo Time. With that, we're planning to do our installation coverage just a bit early, a little bit of buffer room, just in case everything continues to go even better than planned. We're looking at 9 a.m. Central Time to start going live today for installation coverage. That will be covered on the media channels of nasa.gov/live. That'll wrap up our coverage today. Congratulations to the teams here in Mission Control, of course to the JAXA mission controllers in Tsukuba, Japan, and the crew aboard the International Space Station, welcoming 5 tons of supplies inside HTV. That wraps up our coverage today. This is Mission Control Houston.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Would you like to be able to see into the future? That is an intriguing question that has been contemplated time and time again throughout human history. Famous stories from the Oracle of Delphi all the way to the hysteria around the Mayan calendar in modern times have in some way dealt with the idea of humans seeing into the future. This idea has shaped popular culture and our science fiction with that one tantalizing idea of what if. In the real world, the answer to the question of can we see into the future has been answered with a resounding no. In our ever-evolving society, the trend today is to look toward the future by relying on predictive modeling to best predict the probability of an outcome. But we all know that even these well-thought-out predictions based on data often turn out to be not so predictable. Although it's clear that future events remain virtually unknowable, there is one group within NASA that comes as close as you can to seeing into the future. Throughout NASA's field centers, members of the Fixed Wing Project team are peering into the future every day and coming up with concepts that they believe will be on the next generation of aircraft. Because it takes years to plan and develop these concepts, the hardware and theories that are being tested today will be key components that enable the next generation of aircraft to take flight. On this episode of NASA X, follow us around the country as we visit members of the Fundamental Aeronautics Program's Fixed Wing Project, who are developing the framework that will shape how aircraft of the future will fly. Take a look behind the gates of NASA to see what some of these new ideas look like and how the engineers of NASA are paving the way for the ideas that will change the future of flight. To the untrained eye, most of the aircraft of today look very similar. This is because over the past century of flight, aeronautical engineers have worked hard to optimize passenger aircraft to the point where they are as efficient and safe as possible. As a result, the basic tube and wing shape has been configured and examined from every possible angle, making it the most efficient design possible today. Although aircraft have looked basically the same over the past few decades, if you look closely, you can see some of the major design changes. Wings that were once swept back more dramatically now are less so because of advances in aerodynamic shaping. Engines that spewed emissions by the ton are now much more efficient. Materials that were once so heavy that they significantly weighed down a craft are now much lighter and stronger. With all this improvement and efficiency, it is fair to ask if there is anything else that can be done to make flight even better. The answer is of course yes. Behind the gates of NASA, there are scores of researchers who know that we can still make aircraft better because they are working toward these long-term goals every day. Some of these researchers from the Fixed Wing Project are working on so-called N+3 configurations and goals. In mathematical terms, the letter N is where you start now. N+1 is the next step. N+2 is just beyond that, and so on. Here in the Fixed Wing Project, N+3 equates to aircraft that will be flying in around the 2030-2035 timeframe. For this team, everything is on the table, including engines, fuels, wings, and fuselage shapes.
Well, we need to remember the first A in NASA is aeronautics. So it's a National Aeronautics and Space Administration. Aeronautics is the field of research for airplanes. The airplanes that we fly today were researched and experimented within NASA many years ago. So we're trying to continue that tradition, that important work that we have done for the nation and the world for 20, 30 years from now. Fixed Wing is a NASA research program in which we are doing activities to try to improve the airplanes that we're going to be flying in the future. We're trying to make them less noisy. We're trying to make them better for the environment. We're trying to make them in a fashion that they will use less fuel.
The research we're doing is important because air travel it's such an important part of your life. People travel, even if you don't travel. Cargo gets carried every single day. You use something every single day that gets carried by an aircraft. It's part of our way of life these days, and it often gets taken for granted. There are challenges though, so we are focused on exploring and developing technologies and concepts to improve the energy efficiency and environmental compatibility of transport aircraft.
With this mandate to significantly lower noise and emissions and increase performance for subsonic aircraft, there will be a need to address virtually every aspect of the current aircraft configuration, including developing new materials and engines, testing alternative fuels, and even changing the fundamental shape of the aircraft. All across the country, fixed-wing researchers are doing just that. Major advancements are being made into the understanding of how future aircraft will fly. Because there are so many areas of study, let's first look at something that has the potential to be used today as well as in the 2030 timeframe: alternative fuels. On this beautiful morning at NASA Dryden in California's high desert, a test called ACCESS, or the Alternative Fuel Effects on Contrails and Cruise Emissions test, was performed to study the effects of alternate biofuel on engine performance, emissions, and aircraft-generated contrails at altitude. For this test, 2 aircraft were flown in tandem. The first is NASA's DC-8, which will be burning an alternative fuel. The second aircraft is NASA's Falcon that will fly directly behind the DC-8 to measure and characterize the emissions coming out of the engines from the alternative fuel. Here is NASA's Bruce Anderson to explain.
NASA's role is in assessing the combustion characteristics of alternative fuels, as well as determining how these fuels will affect the performance and emissions from aircraft. To understand how aircraft affect the climate, we need to make measurements at cruise altitudes. So the focus of ACCESS, or the alternative fuel effects on contrails and cruise emissions, was to fly behind the DC-8 in flight and look at its emission and contrail characteristics as we changed from standard jet fuel to a fuel that was a blend of a fuel that was made from camelina plant oil, and also added 50% of Jet A to that. There are some other groups out there. Tyson Foods is making a biodiesel and biojet fuel from chicken fat that they sweep up on their processing plant floors. So there's a number of different ways of making these alternative fuels. All of them result in a fairly clean kerosene that doesn't have nearly the contaminants in it that the fuels from refineries do. The fundamental thing is the aircraft has to retain its performance characteristics when you burn a fuel. You can't have any drop in power. The fuel also has to have similar characteristics in terms of density and volume to kerosene. So what we're looking at is drop-in fuels. A lot of the fuel systems on the aircraft are designed to rely on the aromatics in the fossil fuels to swell the seals to make them leak tight. So when we fly an alternative fuel, we have to mix it with standard fuel to retain those properties. Otherwise, the fuel would just leak out of the aircraft. And then the second thing we're looking at is just the emission characteristics. By that I mean the amount of pollutant generated per kilogram of fuel burn.
After the first few flights, it was shown that using these types of alternative fuels could significantly reduce emissions at cruise altitudes, particularly soot emissions. Work continues to better understand how to use these fuels and how to make them even more efficient for future aircraft. Other than alternative fuels, there are some other ideas out there for finding more efficient ways to power aircraft. If we look on our roads today, many of the cars that are now being driven run on a combination of fuel and electricity. The idea that aircraft could do this seemed far-fetched only a few short years ago, but today, this idea is gaining traction. There are several ideas on how to do this, so let's take a look at a few. Here, a team is looking over a new Boeing aircraft design called Sugar Volt. This unique design has several interesting changes, like the truss-braced wings that have the potential to reduce the drag of the wings by making them longer and thinner. Because thin, long wings have the tendency to flex more, designers have included a clever, efficient truss structure to support them. This design has the potential to reduce drag and weight, thereby making the craft more efficient to operate. At first glance, those unique structural changes may look like the biggest game changer for this type of aircraft, but the Sugar concept holds another surprise as well.
In the case of the Sugar concept, what's less obvious to the eye when you see it is that it has an unconventional propulsion system. It's a hybrid gas-electric concept that's closer to what you see in a Prius. It has batteries and a gas turbine engine technology. It requires advances to battery technology, but those are happening throughout the world independent of the aerospace industry, and we're trying to leverage that. We do it on cars, we should be able to do it on airplanes eventually. The challenge is to take those batteries and have enough energy or power content and have them be lightweight. Where we are today, I think, is we're at the dawn of the age where we can start to see electric propulsion or hybrid electric propulsion. And you'll see it on smaller aircraft first before you see it on the large commercial transports. But that's what we're working towards. It's good for cleanliness, it's good for noise, it's good for energy efficiency. Has its challenges. That's why we're working on it, and that's why it's not being done today.
The idea behind this vehicle is to have its twin engines burn fuel when great power is needed, like at takeoff. But when the craft is in a cruise configuration, a switch can be made over to a battery electric mode to supplement or even replace power to the engines. If successful, this could reduce the amount of fuel burn by up to 70%. Another concept called turbo-electric propulsion is being studied here at the NASA Glenn Research Center. Here is NASA's Jerry Brown to explain.
There's not been electric airplanes except in very small size. And the reason is that electric motors and generators tend to be too heavy for flight. We're hoping to change that, and we're hoping to get a benefit from saving a whole lot of fuel in the process. The type of electric propulsion that we're talking about today is turbo-electric propulsion. We're going to keep the turbine engine because it's really good as far as a lot of power in a small power plant. And then we're going to use its power to drive a generator, send electricity to motors that drive fans that do the propulsion.
This concept will look very different from vehicles of today as well. Potential designs include 2 large turbine engines on the wingtips that will drive 2 large generators inside the body. The generators will in turn power a number of fans, providing the propulsion the aircraft needs to fly.
What we want to do here is we want to be able to break the turbine engine from the fan, and that gives the aircraft designer a lot of freedom. If he can move the turbine engine somewhere else in the airplane, that may itself have advantages. The engine and the fans don't have to turn at the same speed. You don't even have to have the same number of fans. And that's what we're really looking for, is we want to have an array of a whole bunch of fans, maybe 15 of them, say, and just 2 engines. You like to keep just 2 big engines because the big engine is much more efficient.
This idea is intriguing, but big changes need to be made to make it viable. One major challenge is the need to reduce the size of the generators, because the generators of today are way too big to fit on an aircraft. One idea that the NASA team is looking at is a way to remove the current type of copper windings in the generator and replace it with superconducting material. This change would allow the generators to shrink, making them viable to fit on future aircraft. We've seen so far, new aircraft designs are coming online that have the potential to greatly improve aircraft efficiency. Another of these revolutionary designs has come out of a joint MIT and NASA study. This unique design is called the double bubble and has the potential to reduce fuel burn by up to 70% as well.
So the MIT-8 double bubble design was something that's we've been working with MIT for a number of years on that. The idea there is to take some of the lift that you would normally get from the wings and try and move that to the fuselage. Another thing that's done to enable laminar flow on this vehicle is to reduce the sweep of the wings. It is easier to maintain laminar flow if the wings, instead of being swept back like a lot of modern commercial transports, are more sort of perpendicular to the side of the body of the plane. Another aspect of the D8 that we didn't really discuss is something you can see in these pictures behind you. You can see the picture on the right, which comes from CFD. The engines are what we call in the potted configuration. They're potted separately off to the side. The idea is we hope to get an airstream that's relatively untainted by what's happening over the airplane, a fresh airstream to go into that engine and create our propulsion. The image in the middle, on the other hand, the engines have been moved to inside that pie tail configuration. And by doing that, we actually get some benefits. If you can use the engines to refill that area of dead air behind the plane, you have a chance at being more efficient in terms of propulsion for that vehicle given a certain amount of fuel. We're trying to sort of push the envelope, see what is the maximum benefit that could be obtained by this kind of a configuration to understand what's really possible in terms of fuel savings.
Aiding much of the work is improved computational fluid dynamics and wind tunnel testing.
Right here in this building, we have Pleiades supercomputer, which is one of the largest supercomputers in the US and in the world. It has 200,000 processors working on the problem if you use the whole machine on one problem. So it's a very large machine, and we need that very large machine because we need to do very big problems here at NASA. The aeronautics research director that we're using it for is to try and simulate the flow over these N+3 configurations. So in order to capture all the detail you'd see on a vehicle like this, including what's going on inside the combustors of the engines and things like that, you need to have a lot of grid points to resolve all the fluid motion inside those engines, over the airplane, and having that many grid points to resolve all that physics in 3 dimensions creates very large computational grids that require very big machines to advance the equations that govern the fluid motion and get these CFD, computational fluid dynamics solutions that we use to make our assessments.
Aerodynamicists of today are able to model ideas on computers, which allows them to test many different configurations before a wind tunnel model is ever built. Once a design is agreed upon, a wind tunnel model can then be fabricated and tested. This process was used for the double bubble as well, but the wind tunnel test showed surprising results.
The good news is we've just completed the first test of this configuration in the Langley 14x22 wind tunnel at NASA Langley. And it showed even a greater reduction or a more fuel efficiency benefit to this technology than we had predicted on paper with our low-hour models. So we're trying to digest the experimental data that show this this nice benefit in fuel efficiency from this configuration. At the same time, we're also using the supercomputer here at NASA Ames, the Pleiades supercomputer, to do computational fluid dynamics CFD runs of these same configurations and see if we can confirm that benefit on the computational side as well.
Testing will continue on the double bubble, and if the results hold, you may see this type of aircraft at an airport near you in the future. When testing aircraft, many different stages occur. We have already mentioned CFD and wind tunnel testing, but another tool in testing future designs is to build a flying scale model. Although CFD and wind tunnel modeling is the mainstay, often test flights of these small, scaled-down versions of an aircraft offer some of the most dramatic results for researchers. That is the case with this aircraft, called the X-56. This aircraft is being used as a test bed to understand how different wing configurations work and how a unique idea called active control may be used in the future.
The whole concept behind the X-56 is that they've long known that a very long wingspan vehicle is more efficient than short wingspan vehicles. Problem is, though, when you get a very long wingspan, you start to get into issues with flutter modes that start to creep into the vehicle, so that the wing will go unstable and in extreme cases will rip off the vehicle. To get around that problem, you can use active flight controls to suppress those flutter modes. Active control is you put things like accelerometers within the wing, and as soon as you sense that the wing is starting to get into these flutter modes, you use the control surfaces behind the wing to damp that out. So the airplane, as it's flying, is continually fighting these modes and keeping the wings straight and stiff. Then you can build a lighter, longer wingspan vehicle that is more efficient. This vehicle, as funded by the Air Force, was built as a multi-utility technology test bed. They call it the MUT for short, and it is built to do a lot of different kind of testing in aeronautics. The wings are removable. You can put on a stiff wing, you can put on a flex wing, you could do a joined wing configuration. We can learn quite a bit from testing this kind of vehicle. Right now, the focus is on flexible wing and active control of flexible wings, but in the future, there are many experiments that can be done with this vehicle.
The research on the control of lightweight, flexible wings being performed today on the X-56 is key to enabling the long, thin, low-drag, and low-weight wings of tomorrow's N+3 configurations. Much is going into understanding what it will take to improve the already incredibly efficient aircraft of today into ultra-efficient vehicles of the future. Although we don't have all the answers yet, it's clear that NASA and its brilliant engineers and researchers are helping to lead the way to a safer and more efficient way to travel.
We are nowhere near the maximum that we can get out of this industry. And there is a lot of work to do, and that's what my team is doing. That's what we're doing within NASA, and I cannot wait for the future.
aviation has always been, since I was a kid, it was a dream for me. I would see airplanes fly, and it was just, I was amazed how an airplane, how such a big object could fly like a bird. You know, my earliest memories, it was probably me and my family were flying back to Mexico, and I vividly remember the pilot saying, "Feel free to come take a look at the cockpit." And I was just amazed at how many buttons and gauges were in there. And I think I created a love for aviation ever since then. I'm Jose Manuel Rodriguez, friends call me Manny, and I'm the crew chief for the G3 at NASA. Prior to this, I was working for a repair station, a charter company in Burbank, California. And they catered to a lot of movie stars with executive jets. And so my experience with Gulfstreams helped me obtain the job here at NASA. A lot of the duties as a crew chief is mainly to manage the aircraft maintenance, scheduled maintenance of the aircraft, along with any troubleshooting, repairs to any systems. Also, if there's any support that needs to be done to any modifications or to any projects that are ongoing on the aircraft. So it's more of a management role, but you do have to take accountability for everything that is being done on the aircraft. So here at NASA Armstrong, we operate 2 Gulfstreams. The G3 is a low-wing twin-engine aircraft. It is pressurized, and it's the transport category. It's certified to fly up to 45,000 feet. Safety obviously plays a big role in aviation. You know, being a crew chief, you have to make sure that everybody's following proper protocol. You've got to make sure everybody's on the same page, everybody communicates, and everybody is doing the job properly. You know, the pilots depend on this aircraft. Not only the pilots, any missions that are being done at the time. For instance, the solar eclipse. We did a mission with the solar eclipse. The unique part about outfitting the Gulfstream in preparation for the solar eclipse was these optical grade windows that we were using. They were manufactured in-house. It gave us the ability to record and transmit live video footage of the solar eclipse from the NASA aircraft so that people could view through the NASA TV live video footage. High definition viewing, photography, and recording. So one of my roles in this solar eclipse was mainly coordinating between pilots and camera crew and personnel.
Get your glasses on, we're going to look out here and...
along with NASA administrators that we had on board that were witnessing the solar eclipse. So obviously lives are at stake. Make sure that everything was hooked up correctly, make sure all the equipment was set up in place, and make sure that the crew was ready for when the moment came.
All right, you're on condition.
It's incredible.
Because we only had one shot to film it, right? And it was a short window that we had to film, so we had to make sure that everything was good. So
see the ring around it?
Yeah. Everything turned out good, and lots of people got to view this live footage, which was pretty amazing.
So cool.
What I love about our heritage, our culture, is we're very family oriented. So family plays a big role in my life. I like, on my days off, on my time off, I like to spend time with the family. I have 3 little ones, and so I try to spend as much time and do activities with them. I believe that if you have a good upbringing, a good childhood, it'll instill good moral values as a human being. My parents, they always tell friends and family, man, my son, I can't believe my son works for NASA and he fixes airplanes for NASA, right? That's their biggest thing. They're like, I enjoy every day working here, and it just gives me a sense of pride being able to help, be a small part and help completing missions and flight research here.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Welcome to Watch This Space. I'm NASA Administrator Jim Bridenstine, and today we're going to be talking about a new program. In fact, a program that NASA is very proud of. We are on the brink of launching American astronauts on American rockets from American soil for the first time since 2011, the retirements of the space shuttles. And so this is an exciting time. We have two providers for this new capability. We call it Commercial Crew. The idea being that NASA is not purchasing, owning, and operating its own rockets this time. In fact, we're going to buy access to space in a way that we've never done it before. We helped two partners, namely Boeing and SpaceX, develop capability to fly our astronauts into space with the hopes that NASA could become one customer of many customers, driving down our cost of access to space and having multiple providers, and those providers competing on both innovation and cost. Again, giving NASA more opportunity to do more things than we've ever been able to do before. And here we are, about a year away from sending our first astronauts to the International Space Station on our Commercial Crew partners. So this is an exciting time for NASA. And we are here today with some very special guests. In fact, these are some of our first pilots on the Boeing Starliner, which is a spacecraft that NASA helped develop that ultimately will be taking our American astronauts to the International Space Station. So with us, we have Chris Ferguson, who is not only a NASA astronaut, but he's a shuttle commander by trade. And in fact, he flew the last space shuttle that we had fly, the Space Shuttle Atlantis, back in 2011. And of course, we also have Sunny Williams, who has done a number of missions to the International Space Station. She's a Navy pilot by trade, as they are both Navy pilots by trade. And in fact, they are both from the test community. So we're very excited to have you both here. And I'll start with you, Chris. Tell me, you have been announced as one of the crews for our first flights of the Boeing Starliner Commercial Crew spacecraft. You were involved in the development of this capability. Tell me, what have you been doing since you've been announced as a crew member?
Well, my life has changed slightly. I've been involved, as you probably know, since 2012 in constructing this. Shortly after I left NASA, Boeing brought me on to help finish the design and take the Starliner all the way to fruition and ultimately into space. So, but in the last couple months, since I knew I was going to be a part of this mission, my trajectory has changed a little bit. I'm a lot more into training and what it's going to take to get Sunny and the rest of the Boeing team up to speed on how the software works, how the crew interface works, how we're going to live and work in space. It's a brand new vehicle. The first time we've done this. It's the first time we've really brought a new human-rated spacecraft to launch from U.S. soil online in almost 35 years. So it's an exciting time for us, and it's great to be back into crew training again. I mean, there is nothing better than training with a group of people who are like-minded and love spacecraft.
So tell me this. Each of you have an astronaut uniform on, yet yours says Boeing. It doesn't say NASA. Tell me about that. Why is that?
So this is going to be a first. As you had mentioned, when this is all complete and NASA purchases services to go back and forth to low Earth orbit, the partner companies that you mentioned, SpaceX and Boeing, will all own the intellectual property that it took to develop this capability with the idea of marketing it elsewhere. So if you had to extrapolate this could perhaps be the beginning of a space line. Boeing builds many airplanes that they supply to airlines. Now we look at a potential business where we build spacecraft to provide a transportation service to low Earth orbit for businesses, for perhaps other countries that are interested in a program of their own. For tourism is always an option, in addition, of course, to the prime NASA customer.
Awesome. And Sunny, tell me about a day in the life of Sunny since you've been selected as a commercial crew partner.
Yeah, it's been a little bit crazy, but fun. I have to say that. Anything you're doing in the space business is fun. Previously, there was 4 of us who were selected for the commercial crew cadre, NASA astronauts, and we divided our time between both companies, SpaceX and Boeing. And now, since the announcement, 2 of us have come over to the Boeing side and the other 2 to the SpaceX side. So we've got to focus our training and attention on this spacecraft. And not only this training, Chris is underestimating the other amount of things that we're doing. We're also doing a lot of testing. Sort of like he was mentioning, this is a new spacecraft, so there's still a lot of things to look at inside the cockpit and how people live in there and how actually we're going to operate it. That's the next step after the development. So a day in the life of might be, to get back to your question, original question,
sure.
is maybe going to the simulator and trying out some manual piloting techniques, which we might get a chance to try in here, or talking through the procedures and looking at how...
So you're telling me in a few minutes we might be able to jump in this thing and give it a whirl? I look forward to doing that.
Yes.
You're a pilot, so
right.
you know what it's like. So some of that, or maybe it's going into the static simulator that we have in Building 9 and looking at how the cockpit is laid out, how the seats are fitted, how the hatch is going to open, where you're going to position some of your stuff, stuff you're going to take, or stuff that going to be 6 months on board the space station. In case there's any problems while the folks are living up there, they can jump into the spacecraft and make their way back to Earth. And that's a really needed capability for sustaining people living on the International Space Station. It's like the Soyuz in its mission. It's a lot different from the Soyuz on the inside of it. The Soyuz, you know, is a heritage vehicle from the 1960s, has a lot of upgrades in the number of years, but it still maintained that shape. This is a brand new spacecraft designed brand new with new technologies and new manufacturing techniques to put this and its rocket together. And so it's a big step in technology. So it's more capable, and it's going to be a little nicer to fly, I think.
So when these spacecraft are certified, the Starliner is fully certified, how many astronauts and/or passengers would a Starliner be able to carry to the International Space Station?
So right now we can accommodate 5. NASA's requirement, what they've asked us for, is 4. So we can barter and trade on what you want to do with the 5th seat. There's opportunities out there for, like I said, tourism or perhaps business. If need be, we built it originally to accommodate 7, and with some minor modifications we could carry up to 7. It really depends on the destination. Right now we have one destination up there, the International Space Station, which is a vibrant and living place. We'd really like to see other destinations in low Earth orbit, however, perhaps commercial manufacturing facilities to give us other places to go.
Absolutely, and of course that's a big piece of why we're doing Commercial Crew. We want to see, in general, low Earth orbit be commercialized in a way that enables NASA to use its resources, enables NASA to use taxpayer resources to do things in environments for which there is not yet a commercial capability.
Right.
So we want to use our assets to go to deep space, go to the moon, go to Mars, where there is no commercial capability. But in low Earth orbit, if we can get to a day where Boeing can take passengers, and that can help offset the costs, and then not just passengers, but also industry. And there's things happening on the International Space Station right now that are amazing. and if we can transition to commercial operations to include the idea that we can use adult stem cells to create human organs that can then be used to extend people's lives. I mean, that's a capability right now under development that could be absolutely game-changing for the microgravity environment, which is only available in space. And if we can commercialize that, and so when we talk about taking passengers into space, we're talking about taking folks that are scientists, that are maybe bioengineers, people that can do things that are unique and never been done before, to commercialize low Earth orbit, and then we can use NASA's resources to do things that commercial isn't ready for yet, which is really an amazing capability. And so we're very excited about what Boeing is doing and what Starliner is, and of course what SpaceX is doing with the Dragon as well. Just so many opportunities. Sonny, you tell me how long you've spent a lot of time in space. How much time have you spent in space?
A little over 320 days.
A little over 320 days. So this time, when you go back, how long are you planning to stay?
Probably 6 months.
Another 6 months.
Yeah, 6 months, and I hope we get to fill the other 2 seats with some of our international partners.
Oh, that's
sort of like
great.
you're talking about, and fill out the complement to make us 7 people on the International Space Station like it was designed for.
That's amazing.
We'll get a lot of work done.
So when you think about your time that you've spent in space, which is an amazing amount of time, how do you think this time will be different?
Well, like you mentioned, right, the International Space Station is complete. And my last mission it was as well, but this will be an additional person to be up there, to be working and doing some of the science that we've been, that station is capable of. And I think we're going to be able to deliver a whole bunch more stuff, science back to Earth. So I think that's going to be different. And of course, the major part is the vehicle that's taken me up and taken me back is going to be different. It will be docked at a different docking port.
Okay.
The space station has 4 docking ports in the aft end for the Russian vehicles, and we'll have 2 docking ports in the forward end for manned vehicles, and then 2 docking ports for cargo vehicles also in the forward end. So it's a busy space station, and it's going to get more busy with all of these vehicles. So it's going to be exciting, an exciting time.
So, so Sonny, you have had the experience of landing in a capsule on land before, and now you're going to do it again. And Chris, this will be new to you because you've always landed on wheels, which of course was very nice. But in this particular case, you're going to you're going to land on land without wheels.
Don't be afraid.
Yeah,
it'll work.
Share with me what is the experience like, and what is the process?
Yeah, so I could talk to Soyuz. I can sort of talk to Starliner. Maybe I'll let Chris talk a little bit more about it. But it's a bunch of controlled explosions as you're coming back into Earth orbit and then landing. Of course, you have to slow down a little bit, so the vehicle will turn itself so it can slow down and start entering the atmosphere. After that, or before, depends on the vehicle, you're going to get rid of parts of the spacecraft because you want the descent module to be the key place that's carrying you and holding you and bringing you back safe. And so the explosions in the Soyuz go on above you and below you, and you can feel it, you can hear it, it's pretty dynamic. You're happy when it happens because that's what's supposed to happen. The next thing, we have a nice big window in this vehicle also. We had a couple windows in the Soyuz. You can see the plasma right next to your head in the Soyuz. When you're on the left seat, it's right here, and it's pretty shocking to see it's only a couple inches away from your head, but we have trust in these spacecraft. This one will be the same, and we'll probably be able to see it from in the big window here. And then finally as you slow down, then the parachute opens up. For Starliner, there's a couple other little explosions too to make sure that the parachute cover is off and then the parachute can come out. And you are in this capsule at the end of the parachute, and of course it's ripping out just like a normal parachute would, and that tends to make the vehicle move around quite a bit. So you're nice and tight in your seat as you are coming in. You're feeling gravity. You want to pull your straps pretty good because you're going to be bouncing around quite a bit just on the parachute. And then once it settles down, don't stick your tongue out between your teeth because you're going to be ready for that landing. And the landing for Starliner is going to be on some airbags. On the Russian vehicle, there's a couple different things that they did. The seat stroked, and then there were soft landing jets that fired right before landing. Here we'll have the airbags come open, and then we'll know we're pretty close to the ground. Get ready. Just sort of get in your seat and huddle down, get ready.
So when I watch
we'll be okay.
When I watch a Soyuz capsule return, that last burst, that last rocket fire right before it touches down, I've seen it start fires.
Oh yeah.
And of course, if you're not used to seeing it, it's pretty startling. You think something went wrong, but in fact, it's supposed to happen that way. In this particular case, there's going to be airbags rather than a rocket burst. Is that right? So the idea of starting a fire goes down.
I hope so.
So if we see a fire now, something's gone wrong.
We always, all of our landing sites are dry lake beds, so there's very little to burn. But at the same time, you had mentioned airbags. What we do at about 3,000 feet off the ground is we jettison the heat shield that just protected us from the heat of reentry.
So hold on right there, because she mentioned the plasma. You were able to see the plasma. When you talk about plasma, you're talking about subatomic particles that have come off of that heat shield, is that right? Which is ultimately what protects the astronauts inside. So that they call it an ablative heat shield. In other words, the heat shield is not, it's intended to not come apart, but it's intended to shed, to burn off its skin, and then that skin ultimately protects you from heat and friction and ultimately crushing the capsule. Is that right?
Right. It's about 2,500 degrees, give or take a couple hundred degrees. But it is, you mentioned the plasma. It is, we have a vehicle that's traveling about 5 miles per second, and you literally slam into the atmosphere, and when you do that, you take those air molecules that were formerly things like nitrogen gas and oxygen, and you disassociate them, and you turn them into just, it's plasma gas. It's just sort of free atoms. And they rapidly dissociate, and they create heat. That heat is carried away by the ablative heat shield, and then they reassociate back over the vehicle. It's really an amazing process. But you do have that thermal protection beneath you. But once you get down below about 100,000 feet of altitude, you won't need it anymore. It's cool enough. And as I mentioned, we'll eventually jettison that heat shield to expose those airbags that will cushion our final landing.
So how do you, when you say jettison, is it burst off by rockets?
There's actually 6 explosive bolts. So Sonny had mentioned there's plenty of explosive devices that occur on the way down. It's going to be a cacophony, and it's going to sound like the 1812 overture, I'm sure, for a period of time there. But there's 6 bolts that hold both the service module, the bottom part that we need on orbit, to the crew module. We'll jettison that before we deorbit, and then finally there's 6 more bolts that will release the base heat shield as we get close to the ground.
Awesome. So the other day I had the opportunity to go out to Huntsville, and I was able to see the components for the Space Launch System, which of course is our deep space rocket. And I was fascinated, and of course both of you are involved in being test for the United States Navy. I was fascinated with how the technology for avionics ultimately compares to that of an aircraft. There's an inertial navigation system that's on board, and it's constantly measuring tiny little movements. And so your aircraft, in this case, your spacecraft or your rocket, always knows where it is: latitude, longitude, altitude, yaw, pitch, roll, trajectory, velocity. All of this data is being collected real time, and then your spacecraft or your rocket is comparing all of that data to where your rocket actually should be. So if there is a difference in where it is and where it should be, it then creates a solution to that difference and maneuvers the rocket nozzles to get the rocket headed the right direction, or the spacecraft headed the right direction. And seeing how it all relates to, these are the same type of things when you think about what an autopilot is on an airplane. It's all the same kind of tech. You've got flight control computers, there's redundancy built in. So share with me, and really for the audience, how has flying test in the Navy ultimately prepared you for this? I'm a Navy pilot by trade. I'm not a test pilot, but a Navy pilot by trade. And I was astonished at how similar the technology is. So share with us, your view on how you were prepared and trained, and how it relates.
So, I think the first thing is to design a good test. Make sure that the intent of the test accomplishes what you need. And, what do new astronauts need in space? They need a vehicle that's safe, that holds the air, that gets it from point A to point B, that knows where it is all the time, that has a system of flight management and systems management computers that can help the pilot along the way. And we mentioned sort of the comparison between older and newer spacecraft. Newer spacecraft are designed to be completely autonomous. As a matter of fact, that is one of our requirements that we work to. So the astronaut is really a systems monitor. So it sort of has turned the test pilot role into more of a I need to watch everything, make sure it's doing what it's supposed to do, and if I need to intervene, I can, but generally I don't anticipate doing so. So I mentioned within 24 hours with very little pilot intervention, we expect to see our vehicle dock, and it can fly with a crew or without a crew. So test has changed quite a bit, but you know, a lot of it's still the same. Is the vehicle safe? Does it sustain human life? Does it get me where I need to be? You know, does it give me the situational awareness I need so I know where I am and I don't inadvertently take over manually?
So in this particular case, we're gonna get in the spacecraft here in a few minutes, and we're gonna fly it. Are we gonna dock it?
You're going to dock it.
I'm gonna dock
You're
it.
going
Okay.
to dock it.
Now, if we were to dock in real life, would it be automated or would it be manually flown?
Yes, we could do both.
Okay.
The design is automation. But you mentioned about guidance, navigation, and control. Do I know exactly where I am? One of what I always think is a miraculous thing of spaceflight is the ability of our sensors to take vehicles that are traveling 5 miles per second relative to one another, and when they bring them together at docking, they're traveling relative to one another of about 2 inches per second.
Amazing.
And that is all through just a series of small orbital burns.
Yeah.
But we can bring it in for a manual approach, which is what you're going to get to try here shortly, or we can give it...
I'm sure I'll rock it.
We can give it to Hal and let Hal fly it. I'm sure you'll rock it as well.
I would imagine as you guys go through training, Sonny, while there is a lot of automation, you don't train for the automation, you train for something else.
Right, and part of that, that whole getting the autopilot ready to work, not only just flying, but how the whole system works, other sensors it's turning on, other systems it's turning on when it needs to turn on for heating, cooling, air, carbon dioxide removal, all of that. We have to ask the right questions to make sure the autopilot does the right things. I think that's a big part of it. And you know, NASA came in a little while after Boeing started designing the spacecraft, and our role as the cadre I was mentioning beforehand was to come in and start asking all those questions. So how does it do this? How does it do this and that? The things that we would expect a spacecraft to do. And you know, some of these things in both companies are a little bit different than the way we've done them in the past. And that's good, because that means it's an advancement in technology. But you know, we all train for also the backup plan. So when something doesn't work by the automation, how do you recognize that? Chris mentioned situational awareness. So make sure you have good situational awareness and know how to automatically take over to keep the crew and the vehicle safe.
That's amazing. Now, when we walked in here, we walked through an area where there were people sitting at computers. And you mentioned that this particular group of people, they were by definition evil, I think is the word that you used. Share with me, tell me why that is. And I know you're just kidding, but what is that all about?
They are not evil. They are wonderful people who are dedicated to the success of every space flight. And you know, astronauts may be the most visible part of the space program, but really, you know, to coin a phrase, we're standing on the shoulders of a lot of people who really make this happen day in and day out. And not the least of which is the mission operations team, who actually plan the mission to make sure we have all the consumables to execute it as the way we intend to, the ones that train us to make sure that we know how to respond appropriately to the malfunctions that occur. And some of the veterans that you saw back there have been with us in the space shuttle program. It's great to see them back for the phase 2 of what's human spaceflight going to look in the 2020s. And and one of them I'll even mention by name, Susan Crippen, has just been fantastic. She taught space shuttle pilots how to fly aborted missions in the space shuttle, something we hoped we never had to do.
Yeah.
And every time Susan walked into a room, and she's this diminutive, wonderful person, she made the most macho astronaut shudder because he knew he was in for a hard day.
Yeah.
And she's working as a part of our team today, and it's just great.
So what they do there in that room is they'll start the simulation for us, not only us, but also mission control. So it's a quiz sort of for us and them. And they'll put in malfunctions, like something broke on the space, one of the boxes, some of the computers, something broke, and we have to figure out how to handle that, how to continue the mission, whether or not we take it offline or try to put it back in the set. We work with mission control, and they analyze us and evaluate us and see how we do all together. And we'll do this a lot. And right now it's in the infancy, the growing process, as we're actually learning how all the software works. But once we figure that all out, those guys will be coming up with evil scenarios to stick in there that will make it very hard. But those are those taxing scenarios that we all need to do so we understand the vehicle inside and out.
And to be prepared.
And to be prepared, yep.
A good friend of mine is another naval aviator, John Harrington, first Native American in space, and of course from the great state of Oklahoma, which is my home. So I used to run the Tulsa Air and Space Museum, and he was very helpful to me in those days. And one day he was talking to me about his shuttle flight, and he said, you know, it was amazing because they had done all of this training for all of this time getting ready for the shuttle flight. And then on the day of launch, nothing went wrong. And he said it was a little nerve-wracking because you expect something, you got to be doing something, you got to be busy. And he said nothing went wrong, which means that obviously you guys are well prepared. You've got a great crew. Of course, we've got amazing engineers and scientists that are making it all come together. And we're just so proud of you. We're so grateful for your willing to step up in this new capacity after both of you and all of the others have already done. And of course, this represents a great capability for the United States. A lot of people don't realize launch is now an export for the United States. It was only about 5 years ago. We didn't have really any launch capability. And now, not only do we have domestic launch capability, we have launch capabilities that we export to the rest of the world, which, you know, it offsets the trade balance for our country. And a lot of it is because of our development with commercial resupply to the International Space Station and getting those other customers on board for those specific rockets and spacecraft. And now we're going to go to the next step, and it's not just resupply, but it's commercial crew. And the two of you and so many others are involved in making this really an amazing capability for our country. And it's not just about science and technology, it's about the American economy and exports and making available space to more people than ever before. And that really is going to be transformative for all of humankind, not just for the United States, but for everybody. So we're so grateful for you guys for being here. And I'm looking forward to getting in this simulator and seeing what it is, and ultimately seeing if I can dock with the International Space Station.
You won't have a problem.
You ready to jump in?
Ready to rock it.
Ready.
All right, let's do it.
4.8, so you're about halfway there. You see these things like dice in the picture?
Yeah.
They're actually our key targets that our cameras are looking at. And you can actually see there's a green line that's surrounding one of the marks on the dice.
Oh, it's so like I feel like I'm afraid to.
No, you're doing good.
You're doing good.
Yeah.
Should I slow down?
Nope. Closure looks good.
You don't want to go too slow either coming in because you want to make sure that
You contact. But you're good at 0.44, about 3.2 meters.
Good.
Oh, well, it's really getting hairy.
Again, that's just your circle getting smaller. Though.
Yeah.
It's not heading the right way.
Give it a little time.
2.6, yeah, just let it react.
Yeah.
Here it comes coming back. Closure still looks good. There you go.
Nice.
That's a good input. Get about 2 meters now, look real good.
You're good, you're good,
You're fine.
good.
Remember, you have that big magenta circle. Really close, about 1 meter now. I think you got this one down. 1.2 meters. Really good. Nav looks good. About 1/2 meter.
Nice.
I don't want it to run away on me.
0.6, looking good. 0.5, closure looks good. 0.3, 0.2, 0.1, 0.1, contact
capture. Nice.
You're in.
I should have been an astronaut. Well, thank you so much. A lot of fun. A lot of fun.
It's all about the Earth and what we can learn about it from the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Station 2 for velocity count ready. You can go ahead and leave steps 4, 5, and 4, 6. We'll move on to step 5.
You want to go right now for that?
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Welcome back. This month on Station Life, we're going to highlight the International Space Station as a platform for studying the Earth and take a behind-the-scenes look at what it's like to live and work aboard the International Space Station. You know, they say a picture's worth 1,000 words. The first pictures taken by humans from space forever changed the way we view ourselves and our world. If you've ever flown on an airplane in the window seat, you know the natural desire to stare out the window. Well, aboard the International Space Station, one of our favorite things to do during our off time is to stare at the beauty of our home planet.
Take a moment every day to look out the window and appreciate where you are.
Literally watch the Earth go by. We're going around the Earth once every 90 minutes. So you see a sunrise and a sunset every hour and a half.
It's just so vast and so vibrant in color, and so much contrast between the black that it kind of overwhelms you at first.
Don't just look out the window during the day. Go for the times between day and night, and then night and day, and take some time to look out into the universe at nighttime, because that's when you can really see all the stars. And you can see that the stars are not only like in a planetarium where they're sort of in a 2D field, they're actually 3D, and some are farther than others.
But you could see the blues and the oranges and the reds and the whites and the yellows, and really see more color about the stars, which indicates more about where they are in their life cycle, what kind of things they're burning and doing. And you would think that you'd get tired of looking out the window, but you never do.
Like I said before, a picture's worth 1,000 words. But in the case of International Space Station imagery, a picture could also be worth 1,000 lives. An imaging system aboard the station called Environmental Research and Visualization System, ISERV, captured photographs of Earth from space for use in developing countries affected by natural disasters. This is yet another way the orbiting laboratory is serving humanity off the Earth for the Earth.
SERVIR is a joint NASA and USAID program where we're working with developing countries around the world and strengthening their ability to use satellites to address the many problems that they have, including floods, fires, harmful algal blooms, and other types of events that they have where they can use satellites to really make better decisions.
We're using space information to help decisions that affect people in the village where they live.
When there's a major disaster, governments around the world come together and they provide all of the satellite data basically that the world has to offer. But there's smaller disasters that occur in the countries that we work in that may not make the front page of the New York Times, but in that country it's a really big deal. We asked ourselves, could we make a difference if we had a dedicated imager for acquiring imagery quickly after natural disasters, and to be able to provide that imagery back to the countries that need them, that have real decisions that need to be made with a very quick turnaround. As NASA, we looked in our own backyard and started thinking, could we use the International Space Station? The International Space Station was really a fantastic asset to take advantage of because it passes over 90% of the Earth's populated area every 24 hours. We developed an imaging system and we called it ISERV, which basically is a camera and a telescope system that sits inside the International Space Station and can collect imagery when it passes over natural disasters or other events that we need to collect imagery.
Initially, we were planning to take a few pictures per day.
So we contacted all the USAID missions around the world, and in total we had more than 2,000 requests coming, for people who need images from ISERV.
And we moved to like 1,000 images per day.
We provided ISERV imagery for many, many natural disasters, including floods and fires, for deforestation, for volcanic eruptions, for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
And now we have a huge archives of images of areas around the world. So this is something that was not really there before.
ISERV is an example of, in essence, making the International Space Station even more international and connecting space to village to better understand and protect our home planet.
Imagine bread loaf-sized satellites zipping around the Earth each day, imaging the globe and providing updates on the environment. Thanks to the International Space Station, this constellation of satellite image gathering has been made a reality. With the mission of photographing the majority of the Earth every day, Planet Labs created small satellites, individually referred to as doves, to capture ground imagery for use in humanitarian, environmental, and commercial applications. With the 2005 NASA Authorization Act designating the U.S. segment of the station as a national laboratory, the space station drives growth of a robust commercial marketplace in space through endeavors like Planet Labs. The Earth imaging mission of Planet Labs' Dove satellites takes another leap toward creating benefits on Earth, resulting from innovation in space.
What happens if you wake up in the morning and you understand the state of the world as it is right now?
What could that data enable? How could people make smarter decisions? How could, for example, a farmer get better yield on his or her crops? How could somebody help disaster response? How can we use satellites to help humanity? That in many ways was the underlying thesis of doing Planet Labs, was to get data into the hands of people that could enable us to make smarter responses to that.
Planet Labs set out with the mission to photograph the entire Earth every day. And they thought, how are we going to do this? They said, let's build our own satellite.
Commercial imaging satellites, they're very large. They are very expensive. We took a different approach.
By making them really small, we can launch lots of them, and by launching lots of them, we can cover this, to get to this mission of imaging the whole Earth every day.
If we can do that, then we can literally change the way that we see the world.
And they called it the Dove. It's about the size of a loaf of bread.
Our doves are basically mainly a big camera with a telescope looking down to take pictures of the Earth. We initially developed the first Dove satellite in our garage. So we kept on iterating the Dove design, we made it better and better, and eventually we put our first one into space. We had no idea what the quality would be like.
I mean, we didn't know if it was going to work.
But we got an image down and it was so beautiful that we knew at that point we could make this technology work.
Wow, we can really do this, and we can achieve this mission, which is something that is really needed for us to understand global change.
So we had done a couple of demonstration satellites, but the next steps we wanted to do was to scale it up, to test the first fleets of satellites.
But what made that possible was actually access to space.
So here's the problem, that in order to take pictures of the entire Earth every day, you're gonna need more than one or two satellites. You're gonna need a whole lot of satellites, and you're gonna need to be able to deploy them really fast. And really, there's only one obvious choice on how to deploy that, and that's the International Space Station.
There was no other platform in the world in order to get access to space of that fashion in that time period than the International Space Station.
NanoRacks is our key partner with NASA.
At NanoRacks, we understood Planet Labs' vision, and we knew that we could help. We worked together to figure out what was going to be the best way to get as many satellites as possible, and we basically developed a new platform. It goes out of the GIM airlock. It's picked up by a robotic arm, pointed out into space, and it fires these little satellites off of the space station.
They were able to secure 28 of our satellites to be launched from the International Space Station, and that was known as Flock 1, our first constellation.
This opened up the whole world to satellite developers, people that could put things into orbit fast.
We now deploy these on a regular basis from the International Space Station. And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The International Space Station does enable young, small companies like ourselves to get going in space.
The ISS provides a lot of opportunities for commercial companies to test and find where the market in space is going to be.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
I used to think when I was growing up in Florida, lots of thunderstorms in Florida, you know, that here's this storm over top of me, and it's just this individual little thing that just is about a storm over Florida. And in fact, now after looking at the Earth from space, I see that that little storm in Florida is connected to Africa and Europe and all across the planet. And one of the most impressive things to see is how the Earth presents itself as alive when you're watching these storms at night just trickle across the whole surface of the planet like its own nervous system. And the emotions of the Earth, you know, seeing storms that are developing, and the way you know from having that experience on Earth how it's probably impacting the people and the places down there. It's like, oh, is it upset and mad today versus the sunshine over some other part of the planet? And really, really, really gets you looking at it in a different way, an appreciative and respectful way. When you're crossing the deserts in Africa, and the way the dunes form, and they almost look like little, you know, birds have run across the sand. And then this contrast you'll get from kind of the pinks and oranges and whites to these dark grays and almost deep blues and of rocks and everything that are intersecting with it. And the Bahamas and the northern coast of Venezuela, which quite honestly is, I think, the most beautiful place on our planet. It is just incredible.
Well, so far we've learned about using the ISS as a platform for iServe, which captures imagery of the Earth to provide disaster assistance, and deploying small satellites called doves. We expect good things to come from both of these experiments and look forward to their robust potential. NASA has selected proposals for 2 new future instruments, Getty and EcoStress. These sensors on the ISS will give scientists new ways to observe how forests and ecosystems are affected by climate change. Our next piece is about a recently completed mission of an Earth-observing instrument on the ISS called HICO. Its name stands for Hyperspectral Imager for the Coastal Ocean. Check it out.
Carroll Township's a very rural area in northern Ohio, right on Lake Erie. Lake Erie's always been very important to Carroll Township and its residents. We use it for drinking water, we treat it, and it's really our livelihood.
In Lake Erie, for what unknown reason, suddenly the toxin level spiked, and that got through the treatment system.
It was indicated to me that it is pretty dangerous.
Cyanotoxins can cause skin rashes,
Headaches,
nausea,
vomiting, stomach problems,
nervous system problems,
liver damage,
to death.
We sampled, and we had about 2.5 times the limit from the World Health Organization. The second sample was approximately 3.5 times. Our plant wasn't set up to handle what was coming in from Lake Erie. One of my biggest worries was actually hurting someone or even worse. So we shut it off right away, shut everything off. We had a very close call that day. The last thing you want to do is produce an unsafe water and allow your people to drink it. What we need is a better way to track and predict these cyanobacteria entries from our source water so that we can make sure that this never happens again.
A lot of the times we'll find out after the fact that there's a problem with cyanobacteria in the water because the blooms already occurred. We either get results of sick animals or sick people. We need a paradigm shift. We need to go from being constantly reactive to these blooms to having a capability that allows us to become proactive. And the U.S. Environmental Protection Agency has been very encouraging of allowing for some high-risk, high-reward projects. And that allowed us to think outside the box, way outside the box. We've been fortunate enough to make use of a sensor on the International Space Station called HICO, which stands for the Hyperspectral Imager for the Coastal Ocean.
HICO consists of 2 instruments. One is a camera,
And the second instrument is a spectrophotometer, which actually gives us the spectrum of light leaving that water.
The camera on a cell phone, for example, contains about 3 bands of data in a red channel, a green channel, and a blue channel.
HICO gathers light from the red, orange, yellow, green, blue, indigo, and violet parts of the spectrum. So using this technology, we're able to now detect those water quality parameters such as water clarity, what the phytoplankton concentration is in your water, how much light is being absorbed in your water, as well as what's the distribution of cyanobacteria in those waters, and does that concentration pose a health hazard?
So what this means is instead of waiting for someone to report that there's a problem with cyanobacteria bloom, we can monitor these water bodies from space
and get information that we can rapidly get out to the water quality managers through a smartphone application that we've developed.
So the app allows you to drop a pinpoint, and that pin can be placed in an area where a drinking water treatment plant may have an intake, and see what the current water quality conditions were. Each user gets that information near real time, so they can make judgment calls on whether they have to respond or take action.
Having the HICO on the International Space Station has been the ideal test bed for our research.
This is an amazing partnership. The Naval Research Laboratory had HICO on NASA's International Space Station. As HICO acquired a scene, it was transferred to the Naval Research Laboratory. And then the Environmental Protection Agency was able to do the analysis and the validation to send this information out through a prototype mobile application. Yes, this technology will reduce costs and provide near real-time information. But the big goal here is protecting humans. And if we can reduce exposures both to humans and even animals, then we've achieved our goal.
Our International Space Station is an unprecedented research platform in space, allowing researchers and scientists to conduct experiments that can't be done anywhere else. Utilizing the ISS as a ready-built platform for studying the Earth is well underway. So far, we've learned about iServe, Planet Labs' Dove satellites, and HICO. 2 more experiments, or payloads in NASA speak, are on schedule to get to the ISS later this year. There's SAGE-3 and Lightning Imaging Sensor. SAGE-3 will measure ozone and other gases in the upper atmosphere to help scientists assess the ozone layer and how it's recovering. And the Lightning Imaging Sensor will monitor global lightning for Earth science studies and support operational weather forecasting and warning. Looks like utilizing the ISS to further benefit all of humankind? It's right on track. Thanks for joining us on Station Life at our behind-the-scenes look at using the International Space Station as a platform for studying the Earth. And be sure to follow us on Facebook and Twitter for the latest research news. And don't forget to download our straight-up gangsta app on your mobile device. It's totally legit. Until next time, we're working off the Earth for the Earth.
Ever think you might want to be a scientist? Or that you could work with NASA? Well, thanks to citizen science programs, you can. Find out how next on Real World. When you picture a scientist, what comes to mind? A person in a white coat? Someone stuck in a lab? Actually, scientists are pretty interesting people doing some really amazing work. And while some scientists do work in a lab, others work in the field, under the water, or on the computer, the one thing scientists all have in common is that they're looking for answers to some serious real-world problems. But sometimes they need help, so they turn to citizen scientists to assist with their research. So what is a citizen scientist?
I think people are aware that NASA has many different missions. We have missions to Mars, we have missions to Saturn, we have many different missions that are observing Earth. There's all this data coming in, and quite honestly, scientists don't have time to go through it all themselves, and we need people to look at this data to tell us what discoveries might be waiting there for us. So this is a way for the general public to do serious, publishable science with us, results that we need.
One of the longest running citizen science programs is GLOBE, or the Global Learning and Observations to Benefit the Environment program. GLOBE students from around the world conduct research to measure and monitor changes in their environment. These citizen scientists learn to use specific tools before they go out in the field or begin their work on a computer. And they follow a protocol, which is a special set of steps to do their research. Think of a protocol just like following a recipe for a cake. But why are protocols so important?
The most powerful thing about science is that it is a tool to actually discover things about reality. But we all need to make the same measurements in the same way. You have to design an experiment so that anybody, anywhere in the world could do it the same way and get similar results. There's a thing called a scientific protocol, and this means that wherever you are, we're using the same tools with the same precision, and that means we can all compare our results. For example, let's say that somebody asked you to measure the temperature of where you are. Are you measuring in Celsius or Fahrenheit? What time of day did you take the measurements? Did you do it at nighttime or during the daytime? If we simply ask people, what temperature is it, we get all kinds of numbers that don't make sense. But if we specify, it needs to be this accurate, you need to use these units, you need to measure at this time of day, then all of a sudden, we can bring all of this information together and compare it and find trends and make real discoveries about what the world is doing. That's the power of the precision of the tools of science. And that's what a scientific protocol really means.
Citizen science projects may also require you to practice some of your math skills. NASA School, for example, may ask you to estimate the percentage of cloud cover in the sky. Another project might ask for the percent of a leaf that has been damaged by ozone. When the same scientific protocols or steps are used to collect data, that data can be analyzed by scientists to help them better understand the problem they're trying to solve. So what are some other opportunities for citizen scientists to collaborate with NASA?
So which citizen science project should you choose? Well, this is your chance to do a little shopping and let your own curiosity be the guide. The wonderful thing about citizen science is you don't need any special skills to get involved. You, as you stand right now, are prepared to do these projects with us. To me, you really need some curiosity. Are you curious about the planets or about the Earth or the universe? And if you can give us some precision, do the measurements as carefully as you possibly can, that will give us the best results. But you need no special training. Start it tomorrow.
It's pretty easy to get started. Just go to the NASA Citizen Science website, pick a program that catches your interest, then be sure to make careful observations and follow the protocol exactly. Get out there and help. You really can make a difference. See you next time on Real World.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond. It's all about matters of the heart. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life. The focus of today's show is on matters of the heart as they relate to good cardiovascular health. We'll take a look at how NASA keeps astronauts' hearts healthy off the Earth. And we'll take a look at some of the research being done aboard the International Space Station that can keep all of us healthier here on the Earth.
Houston 2 for velocity calculation. Go ahead, lead steps 4, 5, and 4, 6. We're moving on to step 5.
You want to go right now for
You
that
can
activity?
copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Cardiovascular disease, including heart disease, stroke, and high blood pressure, is the #1 killer of men and women across America. Fortunately, many studies have shown that healthy habits, including good nutrition and exercise, are important for maintaining a healthy heart here on Earth. Those habits are even more important for astronauts on the International Space Station. Living in microgravity for 6 months changes our bodies in a number of ways. Without gravity, we lose bone mineral density, our muscles atrophy, and our cardiovascular system gets weaker. Some of our studies have shown that in space, the size and shape of our hearts may actually change, which could make it difficult to do our jobs when we get back to Earth or even land on Mars. On Earth, our heart and blood vessels are well adapted to work against the downward pull of gravity. In space, however, there's a tendency for blood and other bodily fluids to accumulate in the upper body. Let's take a look at one of the consequences of this fluid shift.
We have recently identified that some astronauts experience changes in their vision, which might be related to the cardiovascular system. Our hearts pump blood around our body through blood vessels. Special adaptations in our bodies ensure that fluid is evenly distributed despite the pull of gravity. In space, astronauts no longer experience the downward pull of gravity, and the fluid in their bodies tends to move towards the upper body and the head. Our cranium is a rigid container. As the fluid moves towards the head, it causes the pressure inside the skull to rise. This is known as increased intracranial pressure. The optic nerve travels from the brain to the eye. The increased pressure from the cranium travels down the nerve and affects the eye. It causes the optic nerve to be squeezed, and the optic disc, where the optic nerve meets the eye, to swell. The back of the eyeball flattens as pressure builds behind it, and the blood vessels in the back of the eyeball also swell. These changes can affect the astronaut's vision. One change is that the astronauts become farsighted. A second change is that they can develop cotton wool spots, which represent damage of the nerve fibers in the back of the eye. These can cause discrete areas of vision loss. NASA is working to understand and prevent these changes in astronauts, which may also help us understand and prevent related vision changes here on Earth.
One of the tools we have to study heart health aboard the space station is an ultrasound device, which uses harmless sound waves to take images of the inside of our bodies. Those images can be viewed at the same time by researchers and doctors in mission control. With minimal training on the ultrasound, remote guidance techniques developed by NASA enabled astronauts to take detailed images of their own heart. In our next segment, we'll travel to a small community in Brazil that has benefited from remote medicine techniques that were advanced by the research aboard the International Space Station.
Minas Gerais é estado.
Minas Gerais is a large state. Our territory is about the size of France, and we consist of 853 units and municipalities. There are large distances between our communities and many very isolated rural communities.
Nós estamos utilizando nova tecnologia.
We are using new technology that impacts the quality of prenatal care and the diagnostic capacity of the primary care doctor in these situations involving distant, isolated communities.
Providing medical care for people in remote locations, like distant rural communities or the International Space Station, can be difficult, because trained medical personnel are not always available. NASA research teams develop techniques that enable astronauts aboard the space station with minimal training to operate an ultrasound device using simple printed guides. The ultrasound images are transmitted in real time to a doctor back on Earth, who can make medical decisions without actually being aboard the station. These same techniques have been adapted for use with portable ultrasound devices in communities where expert medical care is not always available.
We are also incorporating the first aid and emergency care components, improving first aid at the scene of the accident and enabling the use of ultrasound to communicate to the medical communication center. In the ambulance, we can use ultrasound in various situations. In those situations where time really matters, in which you have little time to make decisions. The idea of using ultrasound for healthcare is like an extension of the physical examination. You are able to conduct the exam with much more detail. And you can use it at the time to make a decision, or you can use telemedicine platforms to obtain a second opinion from someone at a distance. My name is Joaquim Diniz. I'm a doctor in the town of Manga. In Manga, people live with a particularity, and that is isolation. We have a geographical barrier, that is the São Francisco River, which is both a blessing for the region, but it also isolates us. We live in a region where financial resources are few. People do not have a lot of work, but they are honest, good people who do not have much opportunity. So there are many needy people who need these resources and rely only on this institution to provide assistance. This is a technology that helps us solve many problems. That was the case of a patient who came to the hospital with severe respiratory failure, and the people realized she would die in just 20 to 30 minutes. We talked with Dr. Parzelli, who was training us to use the ultrasound. He came and applied the ultrasound and discovered large amounts of fluid around her lungs and heart. We performed the procedure and drained a lot of fluids. In 20 minutes, 10 minutes, the woman immediately experienced an improvement and in half an hour was already walking. It was like a miracle, a rise and walk. She was dying in front of us without people knowing what was happening. This ultrasound was instrumental in saving the life of that patient.
All right, ladies and gentlemen, boys and girls, space geeks from all over the world, we have with us today a real treat. Dr. Koichi Wakata from the Japanese Space Agency and absolutely one of my favorite astronauts. Actually, in fact, wait a minute. I have a list right here, and I want to prove it. Look, Koichi.
Oh, great note.
TC's top 10 heroes of space travel. Look.
Wow!
He's on there. Welcome, Koichi.
Good to see you, Tracy, here.
Nice to see you, too. Thank you for joining us on Station Life.
My pleasure. I'm always watching your program.
Really?
Glad to be here.
Oh, wow. Did you hear that? I'm so excited that I'm actually honored that you watch our show. It's all about the space station, you know.
Yes. Yes, this is wonderful to be able to explain how wonderful it is to work and live on board the space station.
Yes.
And then today, what are we talking about?
Today we're talking about cardiovascular health.
Awesome.
Yes. And you know a thing or two about that.
Yes, we do exercise pretty much every day.
I was going to ask you on board, did you work out every single day?
I did, because it's not only, to keep, my body healthy, but also it's a very important psychological, I think, relaxation for me. And then the best part of the exercise is the, what is that? The ARED device that we have on board.
Yeah.
It's just sitting right next to the cupola windows. Yes. It's probably the best view gym in the entire world, I
Absolutely.
think. Yeah, you can do the, you know, muscle strengthening exercise, and at the same time, you can see this beautiful, you know, home planet. And what a wonderful place.
That's right, because we have the cupola and we have that big center window. We call it window 7. And then most days, because the space station is oriented with the belly of the space station facing the Earth, which means that the cupola windows are facing the Earth. And there we are on the ARED, above it, below, however you want, whatever your perspective is. But anyways, we're right in line looking out that window, which seems to us like we're on a bench. We're doing our bench press and we're looking out that window. And I remember doing my exercise one day and I saw red soil go by and I'm like, that's Australia!
Exactly.
Like yes. You can practice geography at the same time. Can you tell us a little bit about Sprint and what that was all about?
Right, Sprint exercise is a new protocol, and already several astronauts have tried that method. And basically, it uses the prescription of like a higher intensity of exercise, but less volume or less number of exercise days. For example, like if I onboard the space station 7 years ago, I pretty much exercised like running for 40 minutes in the same pace. But here, as far as cardiovascular is concerned, we have like a sprint running, like for 30 seconds sprint, and 15 seconds rest, another 30 seconds of run. But it's only like 6 or 7 minutes, very short interval, but high intensity training. And you do that like 3 times a week instead of 7 days a week.
Wow.
And so it's like a smaller number of days of exercise, but the higher intensity. And that's part of the sprint protocol. So 7 years ago when I was on board the space station, I used the previous protocol, which I exercise every day. But this time, it's a smaller amount of time actually. But the results were pretty good. I was able to walk right after landing. And so I think this new protocol is working very well.
Wow, so if you compared when you were on board and landed 7 years ago to now, when you did this new protocol and you exercised more and you had probably more emphasis on the exercise because you have more equipment to work with. A big difference, did you notice?
As for after landing, I don't see very much difference. So that means that's such a very efficient way to do exercise, because if the results are the same, you know, if you spend less time in exercise, that means it's a very efficient way of exercising. So maybe we can utilize that in the future when we go to, you know, beyond low Earth orbit, when we go to Mars, and then so a lot of new protocols are being tested on board the station.
Yeah, and I can see where folks back here at home who don't have time to exercise pay attention to this, because you can spend less time working out and get the same benefits as if you were working out for what, 2 hours or something.
Right.
And you have done just a tremendous amount of work, Koichi, not just in your most recent increment, but throughout your career in the space program, and you've been an asset to Japan and to NASA and to the International Space Station and to Station Life. So thank you so much for being here with us, spending so much time sharing your stories. We've just had a lot of fun with you. So wish you all the best as we go forward. I'll see you, probably in 5 minutes, but, thank you so much for being here with us.
I enjoyed it. Thank you, Tracy.
Likewise.
Glad to be here.
Cool.
Just curious. I think they can access the ice here. Yeah, depending on how much water pressure we have that day. We can do 16 to any mile at pretty much any time. If we have good water pressure, we can get you up to around 80. But you're saying Tracy's taking off on that. No, you're the one I'm going Okay. Thank you for that.
So with all this exercise going on, is it really working? Researchers and ACERs, who are astronaut strength conditioning and rehabilitation specialists, have made great progress. Before we had a full gym on the space station, our astronauts needed quite a bit of recovery time back here on Earth. Today, our astronauts are coming home in excellent health.
My name is Mark Williams. I'm the lead astronaut strength and conditioning coach. On board at the International Space Station, we have 3 pieces of hardware. We have a cycle, which we call CVIS. We have a treadmill, which is called T2, and we have a resistive exercise device, which is called ARED. And each device is specifically designed to do certain things for the astronaut. We try to do one of those particular devices every other day. One of them we're going to get a little bit better cardiovascular fitness out of it. The other one we get a little bit more impact loading, like running on the ground. So that affects muscle, it'll affect a little bit of bone, does things. Those are the physiological aspects of it. But then also making sure when they come home from a 6-month flight that they don't come home like a bowl of Jell-O. You know, they're going to lose muscle, they're going to lose strength, they're going to lose bone, they're going to lose cardiovascular fitness. But at the same time, then we have to take them, get them back to where they were before they left, which is what we do in our post-flight period once they come home for about 6 to 8 weeks, and just get them prepared back to normal life, you know, doing their job, doing with their family, doing yard work, whatever that happens to be.
Have you ever been sedentary for a long period of time, like lying in bed for a week because of an illness or surgery, and then stood up quickly? Did you feel like you might fall or that not all your senses were functioning? Hi, I'm Dr. John Charles with NASA's Human Research Program. During the 1-year International Space Station mission, NASA will conduct functional studies to gain insight into key physiological factors that contribute to changes in performance. Just like it would take minutes, hours, or even days for your body to acclimate to standing after lying in bed for weeks, it takes time for an astronaut's body to acclimate to an environment with gravity after working without it for many months. 2 tests will focus on post-flight tasks and procedures that will be vital for an exploration crew that has just landed on a planet after a prolonged period of weightlessness. The functional studies will assess how the neurosensory networks, eye-hand coordination, fluid distribution, cardiovascular, and skeletal muscle performance all work together to accomplish an integrated task or function. Researchers hope to compile a post-flight recovery timeline and develop and validate tests to define acceptable performance and define the linkage between physiological changes and functional capacity. This information will be helpful for astronauts and researchers as they prepare for future long-duration missions to asteroids, Mars, and beyond. To learn more about NASA's Human Research Program, visit www.nasa.gov.
So now let's hear from one of our researchers who is studying the cardiovascular system off the Earth for the Earth.
My name is Stuart Lee. I'm the lead research scientist in the Cardiovascular and Vision Laboratory at Johnson Space Center. So the astronauts in spaceflight is somewhat analogous to if you took one of us on the ground and told us not to exercise for a long period of time. So spaceflight has allowed us to see the deconditioning effects, and we can see all the negative things that can happen when you don't exercise, when you don't do physical work every day that we're actually genetically designed to do. So I would say that cardiovascular health is important from the aspect of the heart and the blood vessels are the communication system in your body. So the experiment that they're demonstrating in the background is the primary measurements in our cardiovascular experiment called CardioWalks. And it's primarily looking at the health and function of the arteries in your body. In this particular case, they're scanning the brachial artery, and we use that as a surrogate for the arteries in your heart, the coronary arteries. So we're able to see how they would respond to stress. And obviously, if they respond well, then we've got good cardiovascular health, and it has a good prognosis long-term for the health of the heart. So they're looking specifically at how the vessel expands and contracts with each heartbeat, and then we stress the vessel and we see how well it expands. And those are key functions in your ability to adapt to stress when you're exercising or when you're experiencing orthostatic or gravitational stress. And so it gives us a way that we can look at throughout the mission and after the mission how the crew members are responding to the spaceflight experience. So CardioX is looking primarily at the health and fitness, as you might say, of the arteries. The unique part of CardioX is we're actually looking at 5 years after the mission. So most experiments just look pre, some in and post-flight. We're actually interested in long-term health of the crew members 5 years later, were there stresses involved with spaceflight which might have caused some issues for them. SPRINT is another experiment that looks at cardiovascular, but it looks primarily at the cardiovascular fitness end of things, how hard you can work. We call it VO2 max or maximal oxygen consumption. How hard you can get your body to work during space. And the VO2 max test is very good because it's an integrative test of the cardiovascular system. It brings together all the function of the cardiovascular system so you can work as hard as possible. So these experiments together give us an idea of what's happening on the functional side of things, the SPRINT study, and then on the I don't want to say pathological, but on the health side of things with CardioX. And then with the CardioX Twins experiment, we're also then looking at how genetics affects those things. My name is Stuart Lee. I'm a lead research scientist in the Cardiovascular and Vision Laboratory at Johnson Space Center. We're working off the Earth, for the Earth.
International Space Station provides an unprecedented research platform in space, allowing doctors and scientists to conduct science experiments that can't be done anywhere else. For NASA, keeping our astronauts' heart healthy is vital for continuing the journey off the Earth. Here on the Earth, the keys to good heart health are good nutrition and vigorous exercise. Thanks for joining us on Station Life at our behind-the-scenes look at cardiovascular research being done aboard the International Space Station. And as always, be sure to follow us on Facebook and Twitter for the latest research news, and download our app, which is legit, on your mobile device. Until next time, we're working off the Earth, for the Earth.
Some of us have been in this mission for 20 years. It's a lifetime project. I'm Domenico Giardini. I'm an Italian living in Switzerland. I work on earthquakes and therefore I will work on Marsquakes. I'm a professor at university. Seismic risk, seismic hazard are my main field of applications. InSight is a mission which is geared to measure the physical parameters that help us to characterize the interior of Mars. There are two main reasons why it's important to do by international cooperation. There is a big motivation coming from all the different parts to complete it, and the community grows much faster and the knowledge grows much faster. The Swiss role in this mission to deliver the electronics for the seismometer, and we will provide daily routine analysis and check if there are seismic events or meteoritic impact in the planet itself. This is what our students will work on, how the planet developed and what is the future. And that has a direct relevance on how we understand about the Earth. It's so interesting.
Ever wonder what life is like in space? Or what's happening with the science aboard the International Space Station? Well, check out Station Life daily on NASA TV.
Well, ladies and gentlemen, thank you for watching. Welcome to Watch This Space. I'm the NASA Administrator, Jim Bridenstine, and we have a lot of really exciting things to share today. The video you just watched was a video of some of America's finest, and in fact, some of Canada's finest. These are our new generation of astronauts. We call them astronaut candidates. And today we're going to have an opportunity to meet them. But know this. NASA is on the brink of doing some amazing things. We are, for the first time since 2011, on the precipice of launching American astronauts from American soil on American rockets. This hasn't been done since the retirement of the space shuttle. And next year, we're going to do just that. And these astronauts are going to go to the International Space Station on what we call commercial crew. In other words, NASA isn't purchasing, owning, and operating these rockets as we have in the past. NASA is buying a service from our commercial crew providers, in this case, SpaceX and Boeing, and the Boeing vehicle will be launching on a United Launch Alliance rocket. So this is an exciting time. The idea being we can drive down cost and increase access when NASA is one customer of many customers with providers that are competing on cost and innovation in low Earth orbit. So this is exciting for the United States of America. It's exciting for NASA. And here's the big reason why we're doing this with commercial crew, because if we can drive down cost and commercialize low Earth orbit, we can go further. The President has put out Space Policy Directive 1, and he has said that we're going back to the moon. We're going back to the moon with international partners and commercial partners. We're going to utilize the resources of the moon, and this time, when we go to the moon, it's going to be sustainable. In other words, we're going to stay. And we're going to stay with robots and landers and rovers, and we're going to have humans going back and forth to the surface of the moon from what we call Gateway, which is, in essence, a space station in orbit around the moon in deep space. So there's a lot of really exciting things happening at NASA. And the people that are going to be on these missions, the people that are going to be flying them, that next generation of Neil Armstrongs and Buzz Aldrins, they're going to be with us here today. So let's bring out our astronaut candidates and let's get started. In fact, a lot of people around the country that are enamored with who you are and what you're going to do on behalf of the United States of America, on behalf of Canada, and in fact, on behalf of the world. So thank you for being here. Thank you for participating in this. Thank you for letting this audience love on you for a few minutes there. As you can see, a lot of enthusiasm. But go ahead, please have your seats. And I want to start. We'll start with Kayla, and we'll just go down the row. If each of you would take just a few moments, tell us what your name is, where you're from, and a little bit about your background, where you come from, and what got you to the point where you're ready to be an astronaut candidate. So Kayla, starting with you.
Thanks so much for having us here today, sir. It's an honor to be here. My name is Kayla Barron. My background is in the Navy. I served
Go Navy.
Yes, sir. Naval Academy class of 2010, and I served on submarines before coming to NASA. I'm from Washington State.
Awesome. Well, I can tell you, since I've been the NASA administrator, I've had a lot of debriefs from our astronauts who live and work on the International Space Station. I can tell, based on those debriefs, that your experience on submarines, living in close quarters with other people, is going to be very valuable going forward. So thank you for being here. All right.
I'm Zena Cardman. I grew up in Williamsburg, Virginia, went to UNC Chapel Hill, and then Penn State for my PhD. I was a microbiologist studying mostly caves and the deep sea.
Fantastic.
I'm Raj Achari. I go by Grinder. I grew up in Iowa and went to the Air Force Academy and then MIT, and then was an Air Force test pilot before coming here to NASA.
So when you say you go by Grinder, you're, of course, a military pilot. That would be a call sign.
That would be my call sign, yeah.
Okay, fantastic. Grinder. Yep. Thank you.
Thank you.
Good morning, Matthew Dominic. I grew up in Wheat Ridge, Colorado. Went to the University of San Diego for electrical engineering, and went to Naval Postgraduate School as well, Naval Test Pilot.
Awesome.
Good morning. My name's Bob Hines. I grew up primarily in Pennsylvania. Went to Boston University and the University of Alabama. Was a Air Force test pilot. I actually worked at NASA as a research pilot for a few years before getting selected with this class.
Good morning, Woody Hoberg from Pittsburgh, Pennsylvania. I went to MIT and UC Berkeley, and then spent a little bit of time at Boeing Commercial Airplanes before teaching for several years as a MIT engineering professor before getting selected.
Awesome.
Good morning, Johnny Cam. I was born and raised in Los Angeles. I was an enlisted Naval Special Warfare operator, then went to the University of San Diego and Harvard Medical School, became a medical doctor before coming here.
So when you say Navy Special Warfare operator, most of us would know that as a Navy SEAL. Is that right?
That's correct, sir.
Okay, awesome. Perfect.
Thanks, Johnny. Thanks, everyone. Good morning. I'm Joshua Kutrick. I grew up on a cattle farm in Alberta, Canada. I studied mechanical engineering, and prior to coming here, I was an Air Force test pilot. Thanks for having us.
Good morning, I'm Jasmine McBelly, call sign Jaws. I grew up in Baldwin, New York on Long Island, studied at MIT in the Naval Postgraduate School, and prior to coming here, I was a Cobra pilot and test pilot for the United States Marine Corps.
Thank you, everybody. My name is Laurel O'Hara, and I grew up in Sugar Land, Texas, and went to the University of Kansas and Purdue University. Before this, I was an engineer at Woods Hole Oceanographic Institution up in Massachusetts, where I worked on research, submarines, and robots.
Good morning. Frank Rubio from Miami, Florida. Graduated from West Point, 98. Go Army.
Go Army.
And prior to this, I was a Black Hawk pilot and then a family medicine physician working with 10th Special Forces Group before being selected.
Awesome.
Hi, I'm Jenny Seide. I'm a Canadian astronaut. I studied mechanical engineering at McGill University and then did my PhD at Cambridge University. Most recently, I was working as an engineering professor at the University of Cambridge, and I studied fire.
Hi, my name is Jessica Watkins. I'm from Boulder, Colorado. I studied at Stanford and UCLA as a geologist and did my research on Mars geology, most recently working on the Mars rover.
So Mars geology has got to be really hard, especially from planet Earth.
Yes, that's why I signed up for this job.
That's right. So we're going to try to make that job easier for you.
That sounds great, sir.
Awesome. Well, we're looking forward to that. So just so everybody knows kind of the rules of the road here, this is live on the NASA channel. It's also on social media. And there are people out there who might want to ask a question of one of these fabulous astronaut candidates. If you'd like to do that, you can send a tweet and use hashtag AskNASA. So use hashtag AskNASA, send a tweet, and we'll get you in the queue so that you can ask a question from one of our astronaut candidates. In the meantime, if you're in the audience here and you have a question, certainly think about what that question may be. We have folks here with some microphones. We'll get those microphones up to you and you can ask direct questions of our astronaut candidates. So let's begin. I'll start with the first question, and I'll just start with you, Kayla, since you're front and left here, closest to me, so you're in the direct line of fire. What is something that has surprised you about NASA and or astronaut candidate training?
I think what surprised me the most about training so far, given that my background is in submarine warfare, not in aviation, is how much I've enjoyed flying in our training jet, the T-38. I wasn't sure how that would go for me, but I've really had a good time doing it, and I think I learned a lot from training in that environment.
That's fantastic. Now, in the T-38, does every astronaut become a pilot?
No, so the astronauts who have a background in military aviation before they come here, like many of our classmates do, they get certified to be a pilot in the front seat of a two-seat jet, and the rest of us learn how to fly in the back seat.
Okay.
And we use it as an analog for training in an environment that's actually risky. You're operating real equipment, and you have to learn how to communicate and cooperate with a teammate in order to stay safe and complete your mission.
That's fantastic. Now, let me ask you, did you fly at all, commercially or civilly when you were a submarine warfare officer?
No. I was just focused on learning how to operate a nuclear reactor and drive a boat operating under the sea. So that wasn't really my area of expertise, but I've had a lot of fun scratching the surface of that so far.
Well, that's fantastic. Operating a nuclear reactor, that's a tough job, I can imagine, and I'm sure that that will serve you well living and working in space. So thank you.
I hope so. Yes, sir.
All right. Zena?
Let's see. There are a lot of surprising things in a good way. I think one of the most surprising things to me has been how different every day of our training is. You might be in a class learning Russian 1 hour, and then the next hour you're walking to the airport to get in one of those T-38 jets. It's incredibly diverse, and it's really cool getting to do that alongside classmates who come from such diverse backgrounds.
Amazing. Good.
I think what's surprised me is the amount of people and dedication that support all the training things we do. So whether it's, we just recently had Kayla and I just had our first run at the NBL, and just the number of divers that are involved, all the people that show up to support that, whether it's doing space station simulators and having a whole team of people that are watching a control room for basically a full day just to support our individual training is amazing to me, and this really speaks volumes to the fact that every one of the agencies is so dedicated to us succeeding, but really the agency succeeding in the missions we've got coming forward. It blows my mind every time I walk in that, you know, I get paid to do this, and there's usually 10 or 20 other people there to help me improve and get the mission done. So that's been really cool to see.
So this is interesting because there's so many diverse backgrounds on this stage. And of course, when we think about the history of flying, a lot of people go back to Apollo or Gemini or Mercury. And in those missions, it was largely military aviators, of which, Raja, you were one. But now it's a very diverse kind of cadre of folks that we're looking for, and bringing it all together, tying it together in a way where you guys can work together and maximize the opportunities that we get from space is really amazing. And doing that starting in the training environment is impressive. So thank you for those amazing comments. We do have our first question from social media. So we'll go to the social media question. It is, what astronaut do you look up to the most and take inspiration from? And I'm going to open this up to the first person who's willing to raise their hand, and if not, I might end up diming somebody out. So if you had to pick an astronaut that you look up to, who would that be?
Obviously, very difficult question. To paraphrase, or a quote that typically goes with Newton, or not Newton, somebody smart. I think it was Newton, standing on the shoulders of. We're standing on the shoulders of giants, and when I was on board. On board the USS Eisenhower, Neil Armstrong came out to visit, and I was most impressed with just how humble he was, and he was just, you could tell from interviews you've seen with him, he just was mission oriented and just did his job quietly and respectfully, and I think he's a good pinnacle for this job to look up to.
That's amazing, and there's a new movie coming out about his life, which I have seen, and it's extremely moving for those who are interested in space and interested in the history. This is a movie about a person. It's a movie about a person's life. And I got to tell you, when the movie was over, I couldn't move. I just sat there, just kind of thinking about this person's life. So I think that's an amazing individual that you've just discussed, and the fact that you had the opportunity to meet him. Did you meet him when he was on the Ike? Did you get that chance?
Yes, sir. He came out with a couple other folks and came out to the Eisenhower while we were off the coast of Pakistan doing operations in Afghanistan.
Wow. And that shows you his dedication. Long after his military service was over, long after his NASA service was over, he was still focused on being involved in the lives of the people that were doing what he used to do. So that's man. Look at you now. Did you know then that this is what you wanted to do?
Yes, sir. Absolutely.
But it still inspired you.
Oh yeah, huge inspiration. You know, it's always just something in the distance that you knew maybe I'd have a chance to do that, but never really actually felt like I could be here on the stage right now.
Awesome. Anybody else?
Yeah, I'll echo that. I had the opportunity to meet Mr. Armstrong at a Society of Experimental Test Pilots symposium several years ago, and same thing. His humility and acknowledgement of how many people, he was just the fortunate guy that got to be the first one on the moon, but his acknowledgement to the the giant team that is NASA that got him there, you know, and the industry behind it. It was his humility was just phenomenal and very inspiring. The other one that I would put at a close second would be John Young, who unfortunately passed away not too long ago. But his professionalism and his experience and his dedication to advancing human spaceflight was very inspirational as well.
You know, it's interesting you mentioned John Young. If I remember right, he was involved in Apollo, and he flew the space shuttle as well.
Yes, sir. Yeah, very broad experience, and he so he got to walk on the moon and then flew the first space shuttle flight, which was actually my inspirational moment when I was a young kid, getting to watch STS-1 launch, and following that mission is really what kind of set my sights on this initially.
Wow, that's fantastic. Well, thank you guys for that. I was informed that we might have a question from the audience. Somebody want to raise their hand? We got microphones available. You have to both stand up and talk into the microphone.
What was your hardest part of your training? What was the hardest part of your training?
They probably have the hardest part coming up. But that's a good question, because they've been through pretty tough stuff already.
That's a great question. I think I would probably list learning the Russian language first. We learn Russian because some of us may fly to the International Space Station, where we work closely with our Russian partners there. And learning a new language as a 33-year-old adult is pretty difficult.
Try it as a 43-year-old adult.
More generally, kind of reminds me of, I have a favorite quote. I don't know the quote verbatim, but I'll paraphrase. I think it's a Feynman quote. And he says, it's not that hard, but there's a lot of it. And I think that goes for our training as well. We just do such a diverse range of things: flying, being in the neutral buoyancy lab, learning a language, learning systems of various spacecraft. And it's just the range of everything we do.
Awesome. Others? Most difficult thing? Come on, somebody's got to have something difficult that they've done.
I'd have to echo what he said, that the breadth and not necessarily the depth of knowledge is maybe that deep, but just the wide breadth of knowledge that we need to know. Everything from Russian to the International Space Station to flying the T-38. There's something new every day. And recently, some of us have gone to train in the neutral buoyancy lab in the spacesuit. And I had my first run last week, and I found that to be one of the more physically challenging things, in that you have to, the mechanics of motion that we take for granted every day, as simple as lifting your arm up above your head, is completely different and foreign in that spacesuit. And I found that to be very challenging and humbling, and was a lot of fun.
Even for a Navy SEAL?
Even for a Navy SEAL.
Awesome. Well, good. I've got a question I'm going to ask myself, if that's all right. I'm going to take this little point of privilege, since this is my show, to ask a question. And Bob, I'm gonna direct this to you, because this is an important thing. A few minutes ago, we were meeting in another room, just getting to know each other a little better, and you presented me this patch. This is your class patch. So this patch represents all of you and what you're doing. And on this patch, my first reaction was, that's interesting. We're talking about astronaut candidates. We're talking about our brand new class of astronauts. And you give me a patch with a turtle on it. Share with me and the audience why this patch has a turtle on it.
Yes, sir. So during our announcement last summer, Vice President Pence came down, and he helped introduce our class to the country. And during his speech, he told the story about a turtle on a fence post. And if you walk into a field and see a turtle on a fence post, you know it didn't get there by itself. And that certainly translates to every single one of us here. There is a huge support structure behind us, whether it be our spouses and our kids, our parents, our mentors, all that stuff, they all played a huge role in getting us to the point that we're at now. And so much like we were alluding to Neil Armstrong acknowledging the masses that were behind accomplishing that giant goal, we all have the same thing. We have many people behind us that helped get us here. And so that's the class in front of us took that as an opportunity to name us the Turtles, and we've embraced it. And it's a nod to those that helped get us here.
Awesome. That's a wonderful story, and I think it's important. You know, we have here today not just the astronauts, but we have the newest class of flight directors. And we're going to do another show. They might not be ready for me to announce this, but we're going to do another show just like this one with the flight directors sitting in your seats. The reason being because they are just as critical to all of your missions as you are, as are so many others here at NASA, and in fact our contractors and our providers of services. And yet we want to be able to showcase the entire enterprise, and that at the end of the day, you are the ones that are taking on the most risk and putting yourselves out there. But there's an entire team of people behind you doing everything possible to make sure that you're safe and that you're prepared and that we're getting the absolute best discovery and science and exploration from what you're doing. And that is the history and tradition of NASA. So I love the story. I love the patch. I love that you guys are the Turtles, and I appreciate you sharing that. Okay, so yeah. So we've got another question from social media. How is the current research in space helping you to prepare humans for a journey to Mars and beyond?
I'll take this one.
So for everybody, Jessica is the Mars geologist from planet Earth.
Yes, correct.
All right.
Yes, so I think there's actually a lot of different types of research that are going to be necessary to help prepare us for a journey to the moon or to Mars or wherever that destination might be. I think one big piece of that is sending robotics to these places. So both to the moon and to Mars, we have instruments that are in orbit, and then also the rover that I mentioned is providing us with an understanding of these bodies. First, finding a good place for us to go that has resources that we might be able to use. And is also safe for us. Related to that is studying the radiation involved in the journey to, particularly to Mars, how we can mitigate that risk for us as humans. There's a lot of really great work being done on that at NASA, trying to figure that out. There's the engineering aspect as well, working on getting rockets prepared to get us to the moon and out to Mars and back. Is a big part of that, ideally. And yeah, so I think there's a lot that kind of goes into this big picture of human spaceflight. We kind of have touched on that, but we really are the tip of a really large iceberg. There's a lot of people putting a lot of time and energy into solving these tough problems to allow us to explore further.
Absolutely. That's a wonderful response to that important question. And a lot of things that NASA does that a lot of people don't see, but behind the scenes right now, we're developing technology. We've got amazing scientists and engineers that are, advancing solar electric propulsion, for example, to help us get to Mars with what's called the highest specific impulse possible. We want to be able to get there with propulsion that we don't want to have to launch massive amounts of fuel into space to get to Mars. So solar electric propulsion can really help us get there faster. It can help us get there more efficiently without having to launch so much mass into space. We're also trying to figure out the physiology with the deep space radiation environment, the microgravity environment. On the International Space Station, even right now, we've got astronauts on the International Space Station. And of course, we've had astronauts there for 18 years now, which is an amazing achievement in itself with an international treaty. And our astronauts are demonstrating that humans can, in fact, live and work in space. There are no doubt challenges to human physiology, and we're learning what those are, and we're putting in place countermeasures for that activity. So there's a lot happening. What I think is important to note also is that the moon is actually an amazing proving ground. We can go to the moon. It's a 3-day journey home. We know in this room, because we're followers of the history, Apollo 13, which some call a disaster and others call an amazing success, it was possible to bring our astronauts home because it was a 3-day journey home. Had something like that happened on the way to Mars, it wouldn't have worked out. But in this particular case, the moon is an amazing proving ground to demonstrate the technologies, to reduce the risk, to prove everything we need to know about life and science and physiology so that we can ultimately make that journey to Mars. By the way, you mentioned robotics. And that's, again, we have learned so much. The United States is still the only country, and we've done it with international partners, but we're still the only country that has landed on the surface of Mars with landers and rovers. And now we've done it 7 times. And on November 26th, the Monday after Thanksgiving, we're landing on Mars for an 8th time with InSight, which as a geologist, I know you're going to be really interested in what comes from that. We're going to be able to get a 3D image of what the inside of Mars is like. We're going to study Mars quakes. How active is the geology? How often is it impacted with meteors and all of these kind of things that are going to be necessary, not just to understand the planet, but also to prepare for an eventual human landing, which a Mars geologist might be the right person to send on a journey to Mars. So a lot of really exciting things happening at NASA, and of course your insight there is critically valuable. So I'm going to go back to the audience. There has to be another person that's interested in asking. We've got a couple of young folks here, which I'm thrilled to see. And stand up, say what your name is, and then ask the question.
Hi, my name is Aaron. What excites you the most about going to space?
What excites you the most about going to space? Laurel?
I think the one thing, or one of the things that I'm most excited about is just getting to see the Earth from the unique perspective of being in space, where you can see it just all by ourselves out there in the vastness of space. Everybody on the planet, I think that would just be kind of an overwhelming feeling the first time that you see that and give you a really unique perspective on the world. That's
amazing. You know, looking back in history, this December 24th, on Christmas Eve this year, we're celebrating the 50th anniversary of Apollo 8, which of course was the first time we orbited the moon. And we got pictures, for the first time in history, we got pictures of the Earth in its entirety from the vicinity of the moon. And of course that picture has now been, of course, Life magazine and pretty much every publication on the planet covered that, and it really changed the perspective of a lot of people as to, who we are as Earth. We're this pale blue dot in the middle of this ocean of darkness, and how important this planet is. So that's a wonderful response. Did you have a follow-up question? No? If there was somebody else, we'll go here first and then back to you.
Hi, my name's Samiha, and what makes you want to be an astronaut? What drove you, what still drives you to become an astronaut?
Hi, Samia. I'm Josh. Thank you for the question. I get asked this a lot, and when I think about it, if I think back to when I was your age, for example, I tell people that the one thing that I remember more than anything is just being super curious about everything, wanting to explore and look and go farther. And if there was something that I had never done and that I viewed as being very difficult to do, I wanted to go and try to do it, to see what I would learn about myself from doing it. And as I grew up, I developed other interests. I started to become really interested in flying, really interested in science, and then I got into test flying and all the rest of it. But really, the very first thing I think was just this overwhelming curiosity. And on a bigger scale, I think that's really important to us. It's really important to us as humans in the world that we engage in that we're constantly, redefining what the impossible is, pushing limits and looking further. And for me, that's where it started. And I think that's still a big part of why I'm here and why I'm excited to go to work every day. But good question.
I'm gonna dime out. Let's see, Jenny.
So I want to echo what Joshua said, in that curiosity is a big component and a big driver for what we do. It certainly was very motivating in my case as well. And spaceflight is really interesting in such that we know we're going to learn a lot. We don't necessarily know what we're going to learn. I mean, the technologies that come from the fundamental knowledge we gain from exploring are unknown. Sometimes
we learn how much we don't know.
Exactly. It's just this incredible, really a journey. And it's a really inspiring thing. So one of the things I'd be really excited about, adding to what Laurel said as well, seeing the Earth from that perspective, it's also the excitement that comes with what you're going to learn. So that curiosity and I guess push to learn more is incredibly motivating, I think, for most of us.
You sound like a PhD.
I tried to hide it.
Frank, do you have something?
Sure, thanks, sir. I think, I mean, it's funny, we come from very different backgrounds, but I think many of us have similar personalities in that when we were young, we loved to explore, we loved to push ourselves still, and I think that drive is just deep within all of us, and it's neat to, really in our positions, what we do is we represent teams, we represent NASA, we represent our militaries, our schools, and because I think humanity is kind of driven by curiosity and the want to explore. And so to be able to represent that is a pretty neat privilege.
Okay, awesome. We're going to go to social media here real quick, and then I know we've got another question from the audience. Many of NASA astronaut candidates have military flight experience, but what other fields of study are essential for becoming an astronaut? Well, there's a very diverse group of backgrounds here.
So despite the fact that I'm actually one of those military aviators, I'd like to answer this question because this is such a diverse group, and we have so many people that have done interesting things that, you think of the first class of NASA astronauts, it was all military aviators, and I'm really glad we've moved away from that because, we've already heard from Jessica, Mars geologist. We've taken many courses in geology, and so applicable to, we're talking about exploring other bodies out other than Earth, and we've done a lot of analogs back and how that we can look at certain things on Earth and what does that tell us about what we're seeing on these other celestial bodies. Zena studied extremophiles. I would say more about it, but it's way above my head. But we're one of the most exciting things we talk about, the possibility of finding life somewhere outside of Earth, and I think those extremophiles would play into that. We've got Johnny and Frank, who are medical doctors. So much of what we're studying, especially when we talk about long duration missions, is the medical effects on the body and the radiation, the psychological effects, all those things. Woody, Laurel, anytime we've got a question on orbital mechanics or anything, we go to our resident expert Woody, and so many of these things. And Johnny said it earlier. We're studying such a diverse and broad range of things, and all of us have different backgrounds and different areas of expertise that we all need to pull together.
That's a great answer, and I'll just piggyback. You dimed out Zena and you dimed out Jesse, and I will just say, I've been the NASA administrator for 5 months now, and in this time, there have been so many discoveries that you alluded to about, is there life out there? We now know, just since I've been here, we now know that there's liquid water 1.5 kilometers under the surface of Mars. Well, that's a discovery we didn't know when I took the job, and it's funny to see the chief scientist at NASA run into my office and announce this, guess what we just found, and to know that there are going to be people. In fact, maybe the folks here taking those missions to learn even more with human exploration. We now know that there's complex organic compounds on the surface of Mars. Doesn't guarantee that there's life, but it increases the probability that there's life, which is another important discovery, again, just in my short 5 months here. And the idea that methane cycles on Mars are perfectly correlate with the seasons of Mars. Again, doesn't guarantee life, but it increases the probability. So this diverse group of folks that that is in this class is really going to have an opportunity to make amazing discoveries. And of course, if we're successful in your time at NASA, and I can't make any guarantees, some people are older than others, Bob. But it would be amazing if some of the people here were to make that first trip to Mars, and I think that's in the realm of possibility. We're going to the moon. We're going to retire this risk, and then we're gonna prove out the technologies and take Gateway. That first Gateway is about proving technology. The second Gateway is a deep space transport, and that could be our vehicle to get to Mars. So a lot of exciting things, and the backgrounds here are amazing. We had another question from the audience, I think, in the second row here.
Hi, I'm Ryan. I work for NASA CFO. So you guys are going to actually have an opportunity to do something that most people only get theoretically to do. What would you take with you to a desert island? So you're literally, there's no stowage place, and you really have to think hard about what you're going to take. Have you guys thought about that at all?
It's a good point.
I would take Woody Hoberg.
I think I'd take a long-range radio.
Yeah, I would just take a satellite phone.
In all seriousness, I mean, as we look towards the exploration missions, I mean, we've talked about it lots of times, but we are just the tip of an iceberg. So without the ability to communicate back with the team supporting us, I mean, yes, we have very diverse backgrounds, but any one of us on a spacecraft by ourselves would not last very long. So I think communication would be, to me, the most important thing to, to help with the journey and also to share that journey, but more importantly, just to stay alive on the journey, because there's probably a whole bunch of things on that spacecraft I'm going to need help with, or desert island.
Like all right, a great answer. Did you have more? You can.
Okay, sir. Thanks.
There's I've had this question a lot, and the question is, how many applicants were there to be in your class? Does anybody here know that answer offhand?
I think it was somewhere around 18,000. 18,000
people applied for your job. And yet this group here was selected, and of course this was kind of a new thing. Was there anybody on this stage that had applied for the astronaut corps previously? We've got a number of folks. How many times, if you don't mind me asking, how many times does it take? And just so you know, I have talked to astronauts that work here at the headquarters building that have said that they got accepted on their 8th application to be in the astronaut corps. That's how competitive it is, and it shows that this person was qualified, and still, as qualified as you are, it's still extremely difficult to get into the corps, and yet here you are. So if you don't mind, share the experience of the first application, second, third, or whatever, and then ultimately what it was like to finally get the yes. Anyone?
Well, I applied 3 times. The first, I started applying basically as soon as I was old enough. And the first time I applied, I was still in grad school, and I don't think I met the basic qualifications. But then, so this was my 3rd time applying, and I guess that's all I really.
That's good. Yeah. That's awesome. Bob, did you have something?
Yes, sir. I think one of the unique things about the application process that we go through is we get to spend twice a full week with the other people that are also competing for the same job. And that's pretty unique, I think, to most any other job that's out there. And one of the things that our eyes are open to is the quality of the applicants that are coming in. I think most of us would agree that there are multitudes of other people that are just as or more qualified potentially than we are. So we're incredibly blessed and fortunate to have been selected by NASA on this. And we've really, I mean, we obviously enjoy it. We've got a great group dynamic, I think, with our group, and that's part of what goes into, I think, making a good cohesive class for us. To answer your question in the short version, I applied. This is my 3rd application, and I did not interview at all on either of the first 2. So it's an incredible experience to obviously go through that process, but it is very eye-opening. As many may or may not know, as fighter pilots, there tends to be a little bit of an ego that goes along with being a fighter pilot, but you roll into a group like this and you start realizing, I just fly airplanes.
Nice. Kayla, I want to bring you into the mix. You're a submariner, United States Navy, and we got a question from social media, which I think is interesting, about a lunar base. It asks, how would a lunar base or a colony affect the future of space travel? Have you had any thoughts about this? I know a submarine is different than a lunar base, but in some ways, they would be very similar.
I think, as you already pointed out, sir, the opportunity to work on the moon is a great proving ground for future exploration deeper in space. And I think there's a lot we can learn from operating in extreme environments. We're already doing that here on the surface of the Earth. Submarines are a reasonable analog, I think, for the types of stuff we do in space, but NASA also has a lot of really cool analog projects, including NEMO, which is an opportunity to live underwater in basically a submerged habitat and do scuba diving that kind of simulates doing a spacewalk to learn new things. And the lunar base kind of just takes that to the next level. It really would teach us a lot about how we need to operate when we're further from Earth, when we're further from our support team, and when we have fewer resources.
Awesome. I get this question a lot because people want to know, why are we going back to the moon? And of course, we've got geologists here as well. When you think back to the Apollo program, we landed 6 times on the surface of the moon with 12 people, and each time it was in that equatorial region of the moon. And when we think about Gateway and what it is, we're talking about a habitat in orbit around the moon, not on the surface of the moon, but in orbit. What the Gateway will allow us to do is have more access to more parts of the moon than ever before. So when we think back in history, we have not known, people have maybe thought about, speculated that there might be water ice on the surface of the moon. Well, we discovered in 2008 and in 2009 that there is water ice, and we discovered that there's hundreds of billions of tons of water ice on the surface of the moon. So that's one of the reasons. How would it affect the future of space travel? Water ice is life support, in situ resource utilization, utilizing the resources of the moon for life support. Water is, of course, there to drink. Ice, melt it, you got water. Crack it into hydrogen and oxygen. Oxygen is necessary to breathe. And then, of course, hydrogen and oxygen, when put into cryogenic form, that's rocket propulsion. And some of you will be launching on the SLS rocket, which is a liquid oxygen, liquid hydrogen rocket. So this is an important question, something we need to think about. We put a habitation on the surface of the moon. We're going to be able to get a lot more knowledge about the surface. 1969, we landed on the moon, and it took until 2009 before we knew that there were hundreds of billions of tons of water ice on the moon. How much do we still not know about the moon? Could there be, and I don't have an answer, nobody else does, but we know that there are rare earth metals that are extremely valuable. Well, those rare earth metals are asteroid impacts. They're not earth metals at all. Could there be those metals on the surface of the moon where there's not an active geology, where there's not an active hydrosphere, and would they be right where they impacted, a billion years ago or however long ago it might have been? So these are, I think, important questions about the surface of the moon and what comes next for the future of space exploration. I'm going to go to a question that I have here on a card. I mentioned SLS. We mentioned commercial crew going back and forth to the International Space Station on commercial rockets. Zena, I'm going to ask this question for you. When you think about what mission you'd like to be involved in, what do you think about? What would be your dream choice and why?
Gosh, that's a great question, and I think we all have the very corny, boring answer of, seriously, we would take anything. Any
Sure.
I think it's actually most exciting to me that you can even ask that question and that there are multiple options for us to choose from. That's a really amazing and exciting time to be a part of the space program. But to add on to that, I would go on any mission with any one of these turtles.
That's awesome. But you're right. The idea that we've got 2 different, very dissimilar designs with United Launch Alliance and Boeing and SpaceX launching to the International Space Station next year with humans, and at the same time we're building the largest rocket. We're talking about a rocket bigger than the Statue of Liberty. That's got to be intimidating. Not that the others aren't, but what an amazing opportunity in this country to have all of this under development, and now we're on the precipice of seeing it realized, and that some here might have the opportunity to do it. Anybody else want to weigh in on what you want to do? I know, Jesse, you want to go to Mars, so you're all about the SLS, I would imagine.
Yes, absolutely. I would definitely take it. Yes, I just would piggyback on what Zena said. It's super exciting to have those opportunities actually on the horizon, and it's just because of all of the great work of the talented people at NASA that we're even able to ask that question.
Awesome. Anyone else?
Yes, sir. I think I completely echo what Zena said. We would all take any mission and be really excited. I think as an engineer, the fact that we're building a new gateway out near the moon, I think the opportunity to be involved in constructing that is just incredibly exciting. So while I would take anything, that's the kind of thing out there that makes me say, wow, this is an amazing time to be here.
So you were the one they were teasing about, if we need information about orbital physics, they go to you? So maybe you can share for the audience what a near rectilinear halo orbit is? No, don't do that, unless you want to.
I can try. We actually had a good discussion about this at dinner last night.
Sounds riveting.
We are talking about putting this orbital gateway in a pretty interesting orbit out around. It's an orbit around the moon that has a lot of convenient properties. For example, it is easy to change the plane of that orbit if you compare it to, say, a circular orbit like low Earth orbit. And so that gives us a lot of interesting possibilities, like you were saying, sir, with going to different places if we do want to go down to the surface.
Yeah, no, that's right. So the idea behind the gateway, we think back to the Apollo era, we think about a command module. You think back to the Saturn rocket, that massive stack on the launch pad. What actually came back was just that little thing at the very top that had people on board. That was all that came back at the end of the day. Imagine an architecture, which we want to build, that is sustainable, where all the pieces of the architecture are reusable. So what the gateway represents is, in essence, a reusable command module that can go to different orbits around the moon. It can go to the L1 point, it can go to the L2 point. As you mentioned, you can change what that orbit is, which gives you more access to more parts of the moon than ever before to make those amazing discoveries. And so thrilled to have you involved in that activity. Get through candidate training, and I'm sure you'll be involved in all those kind of activities. Did you have something else? Okay. I know we had another question from the audience over here. I've got a lot of questions from the audience.
Good morning. If you were allowed one personal item to take into space to remind you of home, what would that be?
Hi, thanks for the question. I give the same answer to this, and I really like it. At home, I have an old timepiece. It's mechanically wound, and it was built in, say, the late 1800s probably. And it came from my grandfather through father, and I still have that at home on my desk. And to be frank with you, it's amazing to me to sit and look at this and think of that in the short time span of just those few generations, we're sitting here with these people today at NASA talking about actually going to the moon and beyond. Just something fundamentally amazing to think about, in terms of the pace of human innovation, in terms of what we can do when we come together and try to do it. And just in terms of how exciting the future is. So there's probably not weight for that, but if there was, that would be what I would take.
I think for me, if you ask any of my classmates, I really love pictures, which is, I'm always the one snapping pictures on all our trips. So, when I did my 3 deployments, I always carried in my flight suit a little book of pictures of my friends and family. And so I think I'd bring that.
No goldfish crackers?
Maybe some goldfish pretzels as well.
So Jasmine, remind me what you flew.
I flew Cobras, helicopters in the Marine Corps.
Okay. So you would take those pictures on deployments in the Cobra?
I would. I'd carry them in my flight suit pocket.
Fantastic.
Yes, sir.
We had some more questions here from the audience. No offense, but we'll start with the young folks if that's all right.
My name is Jordan, and what was your first reaction when you got to NASA?
Hey, Jordan, thanks for that question. It's a great question. Honestly, so I had this whole speech prepared for saying, well, thank you for the opportunity. You know, it's great that I made it that far, because I was convinced I wasn't going to get it. And so when I picked up the phone, and I actually happened to be at home over lunch, and my wife was there, and so it was a complete shock. And I know that sounds trite, but it really you just never expect to get it. And again, I'm not that emotional of a person, but I started crying. And it was just one of those like, huh, what's going on? Like, what are these things on my face? And, just a little bit, though. It wasn't like lots of crying. But yeah, it was just an overwhelming excitement that I was just kind of shocked by. So
I would add to that, I think the class has covered really thoroughly how we all feel about how competitive the process is, how amazing all of the other candidates for this job were, and how lucky we are to be here. But one note I want to add, especially for you guys visiting, thinking about what you might want to do going forward as middle schoolers. I think that's when a lot of us started to think about what we wanted to be when we grew up in a serious way. And for me, I wanted to go to the Naval Academy. I wanted to be a naval officer. It wasn't super specific. I didn't realize I wanted to be an astronaut until a few years ago. And I've had some amazing mentors in my life along the way see something in me before I even saw it in myself. That's what caused me to want to go to the Naval Academy, to go to grad school, to be a submariner, and to apply to be an astronaut. And so these big things that seem really intimidating, like whoever gets to do that, that could never be me. I think we all sometimes have those doubts, but the important thing is the advice I got from my last boss, Admiral Carter, who works at the Naval Academy, was if you want to be an astronaut, you apply. And if you don't apply, you can't be one. So for a lot of us, you know, talking about the number of times we applied to be here or whether it was our first time or not, if you don't go for it, you'll never get the call. And I think the flight directors probably feel the same way. I don't know the exact numbers, so they'll, I'm sure, upgrade me later, but there's actually been far fewer flight directors than there are astronauts. And it's a big thing to put yourself out there and ask to do something big, but if you don't do it, you'll never get the chance.
It's amazing. Awesome. Anybody else? Go ahead.
So I'd say, as Frank and Kayla have said, a wide range of emotions when I found out. Certainly an overwhelming feeling of excitement, and this amazing opportunity to have a platform as big as NASA to contribute to the advancement of our species. But I would say there's one emotion that I wasn't expecting, and it was, I don't know if guilt is the right word, but maybe a little bit of guilt, because as Bob had said, during the selection process, you're embedded with amazing people who can do just as good, if not better, of a job than you. And knowing that this is a dream that's shared by thousands of people, and we're just the lucky ambassadors that have the opportunity to fulfill this mission. So I think that was an emotion I wasn't expecting.
That's an amazing perspective. The idea is you go through this process, you get to know people, and not everybody's going to make it, and you know that going in. And then when that day comes, when you get selected and your buddies don't, that's a perspective that I have not heard and is important.
I think the best way we can pay that back is just to remember that and do the best job we can.
Awesome. Thank you, Johnny, for that important answer. All right, we're going to go to a final question here on social media. We have time for maybe one answer on this. So if you really have a good answer or you want to be the person, go ahead and make it known. If not, I'm going to dime somebody out. So here we go. What research do you hope to be involved with in microgravity that will help us on Earth?
I'll take that.
Zena.
Sure. Yeah. I think one of the most exciting parts of being involved in the space program is getting to do research that helps Earth as a whole. Everything from how do we combat bone density loss to how do we prevent, the effects of radiation, to how do we do really efficient wastewater recycling. And every technology that we develop for space exploration has some application back here on Earth. And to be a part of a research project that's so much bigger than any of the research I did as an individual before, that's a treat. That's amazing.
That's awesome. There's a lot of things that really have very little to do with space exploration at all that would have benefits on Earth. And I was talking to a gentleman just a few months ago who owns and operates a company that is doing research on the International Space Station. They're using adult stem cells to print in 3D human organs that will be used on Earth. Now, all of this is very experimental, but they're highly confident that this is going to be a game changer. You can do things in a microgravity environment, in a zero gravity environment that you can't do on Earth. And for some of the scientists that are here to be able to participate in those kind of activities that will transform the human condition on Earth. And of course, that's what NASA has been doing from the beginning with all of our activities, from earth science to planetary science and heliophysics, astrophysics. It really has been amazing. So we're going to close here, Zena. Thank you for that wonderful answer. I just want to get a show of hands, if you're willing. Raise your hand if you're interested in going to the moon or Mars. Look at these young folks. What are you guys worried about? Some of you are like, no, I don't want to touch that. I think it's cool they're going, but I don't want to. And that's perfectly okay, because guess what? They need people to help them on the ground as well. So, yeah, I see you raising your hand enthusiastically. You're ready to go, huh? Yeah, oh yeah. But that's okay. Here's what we're going to do. We got to close out this show. And I just want to say thank you to the audience, both online and on NASA TV, and the audience that showed up here today. Thank you all for participating. I think this has been a great opportunity to get to know some of America's proudest, some of Canada's proudest, so we can prepare for the next step, the next generation of what the United States and Canada, and in fact all of our international partners are about to do in space. So thank you for participating. Thank you to the astronaut candidates. We are going to anxiously anticipate, looking forward to you not just being astronaut candidates, but no kidding, doing your missions, and we're going to be following you all along the way. So thank you so much for participating. Thank you for watching Watch This Space. I'm the NASA Administrator, Jim Bridenstine, and we will see you next time. Thank you so much.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.